Hello, this is part 2 of the tutorial Python for absolute beginners. The first part stopped at strings. Now we start with lists. So a list in Python is a built-in type, might contain items of any type. So this is an example where we have 3 items with indexes 0, 1, and 2 of type string. So on index 0, there's the item string A. On index 1, there's the item string with content B. And on the index 2, there's the third item, which is a string content C. Okay, so this is just a case where all of the items have the same type. In this case, it's string, but we might have different types. For instance, a string, an integer, a decimal number, and it's just the same type class list. Similar to strings, there's also the function len, which is built in, which expects a parameter, which is a measurable object. So could be a list, because the function len returns the number of items in the parameter given. Let's look at the documentation. Says returns the number of items in a container. The length of an object, the number of items. So this is the Python documentation, the official Python website, docs.python.org. For the function len, says that it returns the length of an object, the number of items. So the parameter could be a sequence, string, bytes, tuple, list, range, dictionary, set, collection. Okay. Let's see the length computed. We're going to use a local variable here, and we're going to print the value of this local variable. It's 3. So a reminder, this tool window is the run Alt+4 tool window. In here we see the full command line of the process that's being started, which is not that interesting. It's just Python and then the full path to the current file with extension py, the file containing the source code that we just wrote, so lists.py. Then this is the standard output that's generated by our source code. So our source code printed a 3 in here, and then it also printed a new line when print exits. And then on the last line, it's just the exit status of this process. 99% of cases, the exit status is 0, 0 meaning success. So we should ignore the first line and the last line. We should only look at the rest of the lines. And even this empty new line is also to be ignored. So this is the only thing that's really important, this 3, which is actually result, which is actually length of my list. We can see it's 3. Okay. Next up, we can index inside of the list. So we can see what item is in my list at index 0. It's the string A. So this is printed as a list of characters. So it's just one character A. A is being printed, and then print returns and writes to the standard output a new line character. So the terminal advances to the next line. Okay, similar to what we saw in strings, we can also have index and then colon and then another integer, which stands for the interval that contains the start, which is 0, start index, and then does not contain 1. So this will be just one item, the item at index 0, and stops before item 1. So just this item. Okay. And we saw that my list of an integer index returns an item, the item on that position. So in this case, the string, whereas 0:1 returns a list containing all of the items at all of these indexes. The indexes that satisfy this index colon number. So it's a list because it's enclosed in parentheses, and inside there's an item which is similar to this item. We can also look at the types. So it's class list versus class string. And pay attention that the second index is not included. So if we go with 2, that's 0, the index 0 is included, the index 1 is included, and then we stop before 2, not including 2. So we stop at 1. So this is just indexes 0 and 1, which will return a list with these two values, two strings A and B. So this is named array slicing. So the syntax is start and then step. So index 0, 1, 2, 3 is after 2, so this will 0:3 will be indexes 0, 1, and 2, not including 3. And then step 2 means it's going to take 1 and then leave 1. Let's see how that looks like. So it's these 3 items, this part, but then it takes an item, does not take 1. Take an item, not take 1. So it's just A and C, as we can see in the result. And a similar thing can be obtained with a range. Not with range, but with slice. Like this. The same result if we use this syntax with the function slice, or if we use colons. Okay, let's now look at the concatenation. So we have a list, my list. Let's have another one. 2 B, F, and G. We can print the concatenation of these two lists. And it creates a new list with all of the items from the first list, and then the first item in the second list, the second item in the second list, etc. All of the items in the second list. So A, B, C from the first list, E, F, G from the second list. And the concatenation keeps the two lists, my list and my list 2, unchanged. Let's also see that. Okay, so the original lists stay unchanged. The plus list concatenation operator just returns a new value. Okay, we can also use a string concatenation to be the right-hand side of an assignment statement. Like so. So right-hand side is an expression, it's going to be evaluated, a value will be returned, which is list of 6 items A, B, C, E, F, G, and then that list is going to be assigned to my list 3. Control X to delete the empty line, the line. So if there's nothing selected on this line, then Control X will delete the entire line. Control S to save, and Shift F10 to run. Okay, so we get the same output as before. Strings are similar to lists in the sense that they have the string and a list have same features, in the sense that you can call the method function with either a string parameter or a list parameter. You can do string concatenation or you can do list concatenation. You can see what character is at a given index in a string. The same you can see what item is at a given index in a list. But then there are also differences, because strings are immutable. You cannot say string, you cannot do something like this. In strings, or you can say string at index 0 and then assign it a character, because it will say that that is not available. Test ABC, and then if you go test of 0 and try to assign it a value D, that will not work. It gives an error, says that the line test index 0 equals the string D, throws an exception of type error. The string object, the string type, does not support item assignment, whereas lists do support item assignment on line 4. Okay, so now our list, my list 3, which used to have 6 items with values A, B, C, E, F, G, now has 6 items, and on position 0 instead of A there's the string alpha. Then, similar to strings, we also have methods available for strings. So we can put a dot after the name of a variable of type string, of type list. shows all of the possible methods. And we're going to, so there's len, which is size but not a method but a function. There's these ones with 2 underscores, the double unders, dunder. And then there's these 3, 6, 9, 11. Okay, let's look at them. First is the method append. Let's append a 10. So it's the items from the first list, A, B, and C. The items from the second list, E, F, G. And then at the end of list 3, we append the string 10. Okay, so now the length of the list is 7, not 6. Okay, so the list concatenation does not modify at all its operands. So my list and my list2 remain unchanged, and a totally new list is created and returned. Whereas append does take my list3 and changes it by adding a new item at the end of the list. Okay, another method is the method pop. Let's see its documentation. Documentation does not work. Remove and return item at index default last. So we did not specify any parameter. The only parameter could be this one, the index. If we don't specify a parameter, the very last item in the list, which is this G, is going to be removed from the list. So my list3 will only have 5 characters, 5 items, A, B, C, E, and F, and will return the last item, which is the string G. Okay, so pop does 2 things at the same time. Mutates my list3 by removing its last item, which is this G, and then returns that item that was deleted, the G. Okay, so it prints the string G and shows us that the list my list3 was changed, was mutated, and now has only 5 items. Okay, as we saw in the documentation, we can also pop at a given index. So we can give it 0, which is index 0, which is the item with a value string A will be removed. We can also not directly print the popped value, the result of the method pop, but we can also store it in a local variable. And then we can, for instance, print it. Shift F10. So the list, my list3, has only 5 items. The first one, which is the item string A, was removed, and then we have printed it. We can also run this thing in the debugger, the other button, not the run button, but the debug button, which shows us that my list has 6 items, A, B, C, E, F, and G. At line 3, the concatenation happens. We're at line 4 now. On line 4, the first item, the item A, will be deleted. So we press the button step over. It says deleted A, which means that it has assigned to the local variable deleted the value string A of type str. And then mylist3 does not have the first item, the item string A anymore. We can inspect the values of the local variables either by hovering on top of them. So you just move the mouse on top of deleted. It will say it's of type str and has the value string A. Hover on top of my list 3. It says it's a list, 5 items, and the items are the strings B, C, E, F, and G. And we can also see them as individual items. Okay, we can also inspect my list and my list 2. So my list 2 was defined on line 2 and then never changed. My list was defined on the first line of source code on line 1 and has never changed. Step over and step over, and the execution finished after it Python evaluated line 7. Okay, let's delete the breakpoint. So you put breakpoints by clicking on the line number, and by clicking again you remove the breakpoint. Okay, another method that mutates lists is the sort method. Let's say we have a list again of items of type string, of type just one character string each. Let's have these W, V, B, C, and A. Let's sort the list using the method sort, the last one in the list of methods as shown by default by the PyCharm integrated development environment. Shift F10. So A, B, C, V, and W. So the sorting is in alphabetical order. I'm not sure what it's going to do if some items are not of type string. Supports rich comparison type. Interesting. Sorts the list in ascending order, returns none, and the sort is in place, the list is mutated. If you have multiple elements with the same content, the same order, they will not be switched around. Okay. Let's look at how strings work. So W, V, B, C, A. And then text is a local variable of type string. We type dot to see the methods that are allowed. And what method we have for sorting the characters. Okay, it does not seem to have, but it has other methods that mutate similar to the list.sort, such as string.upper. But if we look at the documentation, says that it returns a string. We can see it in here, symbolized with a minus greater than and then str. So it returns a type string. That's why it makes sense so the text string variable is not mutated, keeps its value, because strings are immutable. That's why the upper method is forced to return a new value of type string. Okay, so we have one local variable, then we go text.upper. Upper does not change the local variable text at all, returns a totally new value, which is then assigned to the text2. And if we print these two, we can see that text2 contains the same characters as the text, but just all of the characters are uppercased, whereas text is unchanged. Okay, so the method string.upper cannot mutate. In order to actually do something, it's forced to return a new string. Whereas the method list.sort can mutate the list, does mutate the list, so therefore does not return anything. You can see that it did mutate because the list has the items in a different order. When we print, we want to print the list. Whereas after we uppercase, we want to print the result of the uppercase. Okay, so this is the difference between how methods that would want to mutate behave in the type string versus the type list in Python. This one would want to mutate to make all of the characters uppercase, cannot do that, so it's forced to return a new value. Whereas the method list.sort wants to put the items in the correct order, can do that, can mutate the list, so it returns none. None is a special Python type. Okay, so if you want to go upper, then you need to not print text, but the result of the upper function. Whereas if you want to go sort, you're not printing the result of the sort method, you're actually printing the list itself. So if you use intermediate variables for the result of the two methods, upper and sort, let's see what these two are. So type result1 and then result1. Okay, so we're inspecting the return value of the method string.upper. We're storing that value in a local variable named result1. We're inspecting the type of result1 and the value that's stored in the variable result1. Then we're inspecting the return value of the method list.sort. We're storing this return value in a local variable named result2. We're printing the type and the content of the variable result2. Okay, so result1 is a string with a value of WVBCA, so the same characters but uppercased, whereas list.sort returns none, which is of non-type in Python. Okay, we can see that in the documentation says that it returns str, returns a copy of the string converted to uppercase, not returns the string, does not mutate the string, whereas sort returns none. So this minus greater than none is the type returned by the method. Sorts the list ascending in place and returns none. Okay, the next method that we're looking at from lists is the reverse method. Let's look at the documentation. No documentation provided. Let's see different versions of the Python programming language. Let's just search. Okay, so on Google I went Python, list and reverse. And it doesn't provide a list, a result from the official documentation webpage from Python. But then w3schools.com is a very good resource. So let's look at what it says. Reverse is the sorting order of the elements. Returns a reversed iterator object. Okay, so it's probably storing somewhere what type of sorting did we do, what were the original what was the previous version of the list, at which index position what item was there, because when you do sort and then reverse, it's just like doing nothing. What if we call sort twice? So you can sort as many times as you want. Reverse will just restore the original version, probably. I don't know. Next up is the practice. So it says we should create a list named my list, which should have 5 elements. The items might be of type string, but you can put any other thing. So let's put a boolean in here. So we need 5 elements, 1, 2, 3, 4, 5. So this is a list with 5 elements. We can also have a float. Okay, so this is it. Then it says that we have a local variable of type list with this definition. So for items type string, with values plane, car, ship, bicycle, and we should add the element motorcycle. Okay, on a new source code line. So we have motorcycle. What should we put on line 3 such that transportation means starts having 5 elements with items plane, car, ship, bicycle, and motorcycle? Well, we use the method append. Okay, and the third practice, we should use the pop method to remove the third item and store it in a variable named deleted items. So we start with this list. We should remove the third item, whichever is the third item, the one at index 2 or the one at index 3. Hopefully the one at index 2. So should be fruit, not fruits, right? Says remove the third item. So let's pretend that the third item is at index 2, which it is. Store the deleted value in a local variable named deleted item. Okay, so this hopefully is the result. Okay, this is correct. And now we're going to the next Python type, which is dictionary. So we'll create a new file. Okay, so how do dictionaries look like? They are pairs, KV pairs, so key value pairs. And the syntax is like this. With curly brackets. So the key 1 has value 1. And then separated by commas, you have the key value pairs. Okay. What is not okay? We should have white space after the colon. Okay. We now print both the type and the variable itself. Shift F10. So we're dealing with a local variable named myDict of Python type class dict with contents 2 key value pairs separated by comma, and the first pair is C1 is the key and value 1, the string value 1 is the value. And then the second key value pair has the key, the string C2, and the value, the string value 2. Okay, so this is similar to a list. in the sense that it contains many things. The things that are contained in a dictionary are pairs of keys and values. There is no indexing. You cannot say my dict of 0. It says key error 0. There is no key with the value 0. So this thing was provided between a pair of square parentheses should be a valid key. So C2 is a valid key. The keys should be unique. Let's see what happens if we try to insert the same key into different key value pairs. It says it threw an error of type key error on line 2 is in fact on line 1. Where are you? So it did work, but it did it in the following way. So we declare a local variable myDict of type dictionary. At first, it inserted into this dictionary the key value pair C1 and value 1. And then it tried to insert into the same dictionary the key value pair C1 value 2. It already found a key value pair with a value C1. It deleted this previous key value pair with the key C1 and it overwrote it with this C1 value 2 key value pair. Let's see what happens now. So that's what it is. It found a key value pair with the same key already, deleted it, and replaced it with a new key value pair with the same key. The order in which the order in which the key value pairs are stored inside of the dictionary or are displayed can change. Okay, let's see what warning is generated by the PyCharm integrated development environment. Says dictionary contains duplicate keys, key C1, and we have possible fixes to remove this key, which we want. Okay. As we already saw, in order to get the key value pair at a certain in order to get the value that's associated with a given key, we use square parentheses and we provide as argument the value of the key. So we want to see value 2, we will provide the key of value 2, which is C2. So if we index inside of the dictionary by providing the value of a key that exists, it will return the value of the value that's in the key value pair with the given index value, in the given key value. Okay, let's see a dictionary that's less didactic than this one. with C1 and C2 as keys. So we can use dictionaries to have data that is similar to a list of objects. So similar to a table in a database. Similar to a row in a table in a database. So let's say that we have a customer which has a name and a last name and a weight and a height. Okay, so these are just keys. Let's put values to them. So name, this would be first name. John. Lennon. Weight 81 kilograms and height some float number 1.72 meters. Okay, and so this represents one object, but we're not storing it in a Python object. We're within a customly defined Python object data type, so the one type that we define ourselves, but we're storing it in a more generic dictionary. All of the properties are inside the dictionary keys of type string. So we have 4 properties for our object, and the values of the properties have various types. So first name and last name have value string, weight has value integer, height has value float. So we can go custom. Let's see customer's weight. It's 81 kilograms. Let's see customer's height. It's 1.72 meters. Okay, so similar to lists, we can put anything that we want inside the value of dictionaries. So we can have integers, we can have strings, lists, and even other dictionaries. So we can have dictionaries as values inside other dictionaries. Okay, so let's have a dictionary with item. So 3 items with the keys 1, 2, and 3. In the first item's value, we have the integer. In the second item's value, we have a list. In the third item's value, we have another dictionary. Let's have this be K1 from key1 and integers. And then K2. and then the integer 20. Okay, we can use the integrated development environments feature, which shows the pairing characters. So if we click on the square bracket, the ending square bracket, it will show the match beginning square bracket. If we click on the closing curly bracket, it will also highlight the beginning curly bracket. So we can easily see which curly bracket corresponds to which curly bracket, because we have in here curly bracket pairs inside of another curly bracket pairs. Okay, so this is a dictionary that's stored as a value on this key value pair in this dictionary that's named myDict. So let's see how we do indexing. So we go myDict, and then we need to provide as inside the square brackets the value of a key, which is 1. Let's also print the type. Okay, so if we take the dictionary myDict, search for the key with a value 1, we find this pair, and it returns the value in the pair, which is 44, which is class int, Python type, and the value is 44. So it's an integer. Then let's look at myDict of 2. So this 2 is an integer. There exists a key with a value integer 2, and it's this array, this list. It says class list, and the value of the variable result is the list 1, 2, 3, which is the value of this value. Okay, but then we can also continue working with this thing. So this thing is actually a list. So this is a dictionary, myDict. 2 is a number, a integer, whereas this expression is actually a list, as we saw here. To the expressions of type list, we can apply various operations such as indexing. So we can look at these 3, which is on position 0, 1, and 2. So 2. This is a dictionary. This is a list. We index at position 2 inside of the list, and it should say integer 3. Class integer and then 3. Okay. Then let's look at myDict of 3. There exists a key value pair with a value with key 3, with key value 3. Its class dict has 2 items, these 2 items. Okay, so this is a dictionary. This is another dictionary. So this dictionary is this. This dictionary is this. And with dictionaries, we can select the value of the key 2, K2. So this dictionary is this dictionary. We go to the index K2, to the key value pair with a key value string K2, which is this pair. And we return the value, which is 20. So this thing is evaluated as the integer 20, which is stored in the variable result. we can see it's class int value 20. Okay, and now we read an exercise where it says that we should put on line 2 just one single line of Python source code that will print the letter E, so this character, but uppercase. Okay, so there's multiple steps involved. We have an array, a dictionary. In the value K2, there's this array with 3 items. We need to index here in the second position, which is index 1. We need to take this string, which is a string E, and we need to make it capitalized, so uppercase. So let's see how we do that. First of all, we can go mydict and K2. We'll use the debugger. Let's see if that works. So we know what the value of mydict is. We have evaluated line 1 and now we're evaluating line 2. And it exits immediately. Let's put something in here. A print that doesn't do anything. And put a breakpoint here. Okay. So let's see what mydict of K2 is. It doesn't say. Then let's use an intermediate print. Like this. Okay, so mydict of K2 is what we expected, which is this list. But it says that inside of this list, we must index on index 1. And then it says the program should print just E, but capitalized. Okay, so this is the result. It's very long. It does many things. So goes from this local variable mydict, indexes once to get to this array, indexes twice to get to this item inside of the array. This whole thing is a string, and since it's a string, we can call its functions such as len, we can call its methods such as .upper. This is going to be the string uppercase E, just one character, and print knows how to print it to the console, to the terminal, to the standard output. And then when print finishes, we'll print this new line character. Okay, let's now look at how we add items to a local variable of type Python dictionary. So let's create a simpler dictionary. So 1 has the value string A. 2 has the value string B. We'll print it. Is as we expected it. And now we're writing to the index that does not exist. So we go mydict of 3 and equals C. And then we print again. Okay, so we started on line 1, declared a dictionary. On line 2, we printed it, has two key value pairs. On line 4, we tried to modify the key value pair that has the key 3. There's no such thing. So instead of modifying the existing key value pair with key 3, it inserted a new key value pair with a value with key 3 and value C, which is this thing that we can see here. So our dictionary, myDict, had two pairs, and now it has 3 pairs. To prove that that's what it does, so it tries to find the pair with the key 3. Let's see what it does when it actually finds a key value pair with that key. So let's go, myDict of 2 is uppercase B, Shift F10. So at line 5, we have this value for the local variable myDict. Then we say go at the key value pair with key 2, which is this thing, and write this thing. And set the value from the lowercase b string to the string uppercase b, which it does here. So it was a lowercase b previously, and now it's an uppercase b. Okay, so myDict, and then we're indexing with square parentheses, is modifies the existing pair if it finds it, or adds a new pair if the key does not exist in the dictionary. Okay, let's look at other methods of the objects of type Python dictionary. We have pop, as we saw previously, which removes a key value pair. We have clear that removes all key value pairs. And we have these methods that are specific to dictionaries, which are items, keys, and values. So let's look at keys. So it returned a object of type dict keys with the values 1, 2, 3. So our dictionary myDict has 3 key value pairs, and the keys are 1, 2, and 3. Okay, similar method for values. So 3 key value pairs with values A, B, C, with uppercase B. So the strings A, uppercase B, and then lowercase c. Dict values. Okay, and the other one is dict items. These are the key value pairs 1, 2, and 3. These are tuples, and this is a list. Okay, so we're at the first practical exercise for dictionaries, where it says that we have these values. We should create a local variable of type Python dictionary named myDict, which stores this information. Name Karen, surname Jurgens, age 35, occupation journalist. Okay, so how do we do that? We declare a local variable of type dictionary. All of the properties, as it were, are strings. So all of the keys are strings. Okay, Karen is the first value. Jürgens is the second value. Age is an integer, so we do not want to surround it with single quotes or double quotes because it's not a string. And occupation, journalist. This is certainly a string. So name Karen, surname Jürgens, age 35, occupation, journalist. Looks okay. Next up, exercise number 2. We should use the print function to return the second item of the list called points to. The second item of points to. Ctrl A, Ctrl V. So we have this my dict. So contains just two key value pairs. The first key value pair has key values 1. The second key value pair has the key points. The values are this and this. Starts here and ends here. And the first value ends here and starts here. We can see the highlighting that happens when we click on the curly brackets. So says second item of the list points to. So my dict, let's print it first. Looks like this. We want to go into points to. So this is a dictionary. We go into points. This is also a dictionary. We need to go into points to. So dictionary, key, the key is points to. So we can see that this is a dictionary surrounded with curly brackets, has just one comma, so means it has two key value pairs. The first one with key points to, the second one with key points 1 and points 2 are the keys. Okay, let's print. So now we're inside of a list. Says in the list we need to look at the second item. So the second item is index 1 because indexes start with 0. The first item is index 0, the second item is index 1. Okay, and the third exercise, we have a dictionary. Let's make the ID happy. Reformat the file so it put spaces after the columns. Reassign new values to the keys as appropriate. Add new key called country. Okay, so we need to know what the new value should look like. So this is how it should look like. We have line 1 where we define the variable of type dictionary. We need on line 9 to change the dictionary. Okay, so let's see. The first key value pair is named Karen, stays unchanged. The second key value pair is surname Jurgens, stays unchanged. The third key value pair is age 35, should change to age 36. So let's do that first. So we need to replace this pair with this pair. So we index by the key and we assign it the new value, which is 36. Okay. And then it says occupation journalist, which is the fourth pair. Occupation now becomes editor. So this pair, we need to replace it with this pair, which means key occupation. And the old value is journalist. The new value is editor. So we need to set the new value into this key value pair. Okay. And then it says country, Colombia. So this would be a key value pair that there's no key value pair in the mydict dictionary that has the key of the key value pair country Colombia. So there's no country in here in the keys of mydict. So we just do it exactly as we do it when we want to update existing key value pairs. And then Python will do the correct thing. If a key value pair with the same key exists, we'll update it. If a key value pair with that key does not exist, we'll insert a new key value pair. Okay. Or we could even call mydict of name equals Karen and mydict of surname equals Jürgen. So we might have set all of these key value pairs is the same thing. Okay, let's print it. So name Karen, surname Jürgens, age 36, occupation editor, country Colombia. Okay, so next up is the Python type tuple. Tuple is extremely similar to lists, but lists are mutable. You can say list and then at index 0 set the value to 37, which you cannot do in a tuple. You cannot change the values stored in items in a tuple. Okay, so the syntax is really similar to lists. This is how you would declare a list. So we already know in order to create a local variable of type Python list, you use square brackets and the type will be class list. Let's not have a list but a tuple. And now in here in the output it says class tuple instead of class list. And also when I print the tuple, it shows it enclosed in parentheses, not in square brackets. Okay, and let's prove what we said previously, which is that we can mutate individual items in a list. Okay, so it's 100 on the position item on the position index 0, and then 2, 3, 4, which are this plus this. So we can mutate at index 0 inside of a list. We cannot mutate inside of a tuple. Okay, says my tuple of 0, type error, tuple object does not support item assignment. So we cannot assign a value to an item that's inside of a tuple. That's the big difference between tuples and lists. Why would we use tuples instead of lists? When we want a constant object, an object that cannot be changed by source code, maybe we really want to be sure that no source code can actually modify the values that we store inside of that tuple. There's also reasons of using immutable data types for multi-threading with high performance and no thread locks. So for performance reasons is another possible reason to use tuples instead of lists. Okay, we can also declare tuples by not enclosing it with parentheses at all, and it still works and it's equivalent. So whether we enclose it in parentheses or not, it's the same, at least this time, because Python determines that that's what we want to do to declare a tuple. Okay, then similar to lists, we can have not all of the items have different types. There's no limitation that if the first item in a tuple is of type integer, the rest should be integers. Might be a string or a float. It will work. Okay, so the types that we put inside of tuples might be really complicated types, might be a dictionary that has inside a tuple that has inside another dictionary, etc. Or might be a list. Let's look at indexing. Indexing behaves similarly to lists and to strings, so we can have my tuple of 0 is 1. Let's go back to the previous version. So at index 0 there's 1, at index -1 it's the last item, at index -2 is the penultimate item. Okay, let's see if we have multiple levels of indexing such that we have a tuple and inside we have another tuple. How do we print just this 20? So first of all, if we print my tuple, it will print all of this, so the external tuple. Then we can print this tuple. This is at index 0, 1, 2. Then we want to get at the 20. So we're now this thing has been evaluated to this tuple with 2 items. And we want to go to the second item, which is at index 1. So the printed value is just the integer 20. Okay, there are conversions possible. So we can convert the tuple to a list, for instance, equals list. So a function with the name of the type. The type that we want to convert to is list. Okay, says that we have the list with the exact same items as the tuple, but it's a list because we can see it's enclosed in square brackets and says in here that it's Python class list. And then we can even go back. So we have this list, we can then convert it to a tuple. And we can store it in any variable we want, including in this thing, my list. Okay, so this is a tuple, this is a list, and this is a tuple, even though the name is misleading, says my list. In fact, does not matter how we name our variables, we can put anything in there. We can have a variable named my dictionary and it might have as content a list. So don't trust just the name of the variable, actually inspect it, see what's inside of it. So my list is actually class tuple. We can also see it's a tuple because it's surrounded by around parentheses. We can even do things like we can nest function calls as deep as we want. Now let's see Python packing and unpacking. So this is similar to destructuring in other programming languages. So we have a tuple with 3 items, and then we have 3 local variables x, y, and z, and we assign them all at once, the entire tuple. And then let's see what happens if we print the local variable x, y, and z. So x is not assigned the tuple 1, 2, 3, but instead the tuple 1, 2, 3 is unpacked, and at most 3 local variables are assigned. If we go another one, v, and then v, this fails because says that it looked at the right hand side, which is equals t. T was evaluated to the tuple 1, 2, 3. That was unpacked. Inside of x, try to put a 1. Inside of y, try to put a 2. And these 3 try to put it in z. But it did not expect to also be a v. Did not know what value to put inside of v. And now it threw the error. Says exception value error. Not enough values to unpack. Expected 4 values to unpack, but only found 3. So should unpack 4 values, and in fact only received 3 values to unpack. So actual is 3 and expected is 4. Okay. Let's look now at the methods of the Python type tuple. So we have p dot, and there's functions, the ones with this icon. There's double unders, and there's just 2 methods, count and index. So first of all, let's look at count. Count expects 1 possible parameter, might be none. No, it can't be none. Okay, so we need to provide a value that it is going to count. If you actually want the number of items inside of the tuple, we would use the function len. If we want to know how often an item appears inside of the tuple, we have count. So the item 1 appears twice. And then the other method is index, which searches for items inside of the tuple, similar to how it searches inside of a list, with 3 parameters: start, stop, and what to find. So we want to find the 2. So 2 is at index 0, 1, at index 1. Okay, so value, start, and stop, exactly like it was for strings or for lists. We want to find 1. It finds it at position 0, but we do not want to find this one. We want to find this one. So we should start at position 1. And now it finds this one at position 3. So this is as position 1. This is the first index it should try. So says, is value 1 here? No, it's not. How about here? Nope. How about here? Yes. What's the index of this item? 0, 1, 2, 3. And it wrote a 3. Okay. So we're at tuple exercises. Exercise number 1 says print the number of times the item 2 appears in this tuple. That would be print the name of the local variable, and then we want to count how many times 2 appears. So it appears 6 times. 1, 2, 3, 4, 5, 6. Okay. Then tuple exercise number 2. There's a tuple, convert to a list, and store it in a variable named mylist. So we need to create a new local variable named mylist, and we assign it the value, we declare it with the value, the tuple converted to list. So we have the list function that converts what it can into the Python type list. And it's in fact a list because it's enclosed in square parentheses. Okay, exercise number 3. We have a tuple, and we need to extract the elements into 4 variables A, B, C, and D. Okay, so we have 4 local variables A, B, C, and D. We're going to use unpacking, and our tuple has exactly 4 items. So the unpacking will be successful. The unpacking requires that the number of items in the tuple is greater than the numbers of local variables that we're declaring. So the number of items in the right hand side should be more than the number of variables in the left hand side of the equals sign. Okay, and it works. Next up is the Python type set, which is similar to a list, but you cannot have the same item twice. And you can declare the set in two ways. So let's declare it. My set. We use the function set. It's a built-in, okay, looks like a function. I'm not sure exactly what it is, but it's a built-in. So it's a constructor of the class set, which receives as parameters a tuple. Not sure. Okay, but we're actually giving it as parameter as a list. So says that's it. This thing needs to be iterable. Could be the empty set object or the new set object. Builds an unordered collection of unique elements. Okay, so we have 2, 3, and 4, and 5. Let's look at its type and value. It's of class set Python type, and it's printed by Python like this. So within curly brackets, one at the values 1, 2, 3, 4, and 5. Okay. The PyCharm integrated development environment for programming in the Python source code language suggests that there's another way of declaring a local variable of type set without the constructor of the class set, with special syntax, which is what we saw printed at the console. So within curly brackets, content similar to the content of a tuple or of a list. Okay, let's see that the output is the same, and it is. Let's try to put another item that already exists. This will be silently discarded. So all of the duplicates will be automatically removed when we declare a set. And then inside of sets, we cannot have, let's see what we cannot have. Can we have a tuple? Yes, we can. Can we have a list? No, we cannot, because a list is mutable, so therefore it's not hashable, because the hash of the list might change. Okay, can this be a string? Strings are immutable. Yes. Can this be another set? No, it cannot, because you can add or remove items into a set. Okay. How about dictionaries? Okay, so these are the limitations. Each individual item needs to be immutable, such that the deduplication or the removal of the identical items can be performed by the set Python type. Another way of creating sets is with the set constructor, but then inside we're not going to specify a list as we did before, but we're going to specify a set. Okay, so says that set of iterables, so a tuple or a list are both iterables. Okay, another limitation with sets is that you can't even get the index. This fails because set that the error is exception type error, the set object is not subscriptable. Because similarly to dictionaries, you cannot get in dictionaries you cannot say which key value pair is at index 0. And in here you cannot ask what is the set item at index 0. Because the order is not stable enough such that you can index by an integer value. Okay, let's look at the type set. What does it have? You can use the built-in function len. So len accepts just one parameter, and that should be sized, and sets are sized because it has just 5 items. And it returns the len function returns the integer 5. Okay. Then we can say is an item inside of the set. So is for in set. It is. It returns true. Okay, let's go at the methods. So let's say we have two sets, S1 and S2. So S1 is the set. Where are you? One, two, and 1, 3, 4, 5. It's okay. Okay. And S2 starts at 3 and goes 3, 4, 5, 6, and 7. Okay. We have S3, which is S1, and we have the methods possible. So again, let's look at them. Functions such as len, double unders, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16 methods, 18. Okay, we're looking at the methods that do set arithmetic. So in mathematics, sets can you can apply to two sets the following operations. You have union, which takes all of the items that exist either in the left or in the right set. Intersection takes all of the items that exist both in the left and in the right union. Difference takes the items that exist just in the left union, do not exist in the right, or just in the left set, and do not exist in the right set. So the two sets are operands, and the operators are these ones: intersection, union, and difference. So let's see union first. You go S1, union, and union has just one parameter, which is the other set. Okay, let's see what type is returned by union. It returns a set. Okay, Shift F10. So it's class set, this type 3, and it has 7 items. So S1 has 5 distinct items. All of them appear here. And then S2 contains the item 3, that's already in the union. Contains 4, it's already in the union. 5 is already in the union. And then 6 is not in the union, will be added. 7 is not already in the union, will be added. So that's why 7 items. So it's very similar to concatenation. If you could concatenate these two sets, then sets cannot contain duplicate items. So Python will automatically do the duplication. Okay, let's look at more methods of S. So we go S1 dot, and let's see. Because it's mutable, we can have the methods add, which does nothing if the item to add already exists. Adds the item if it does not exist in the set. Then there's the method remove, which if it finds the item will remove it from the set, otherwise it will throw an error. There's discard, if it finds the item in the set will remove it, otherwise will not do anything. And then there's pop. Okay, so let's look at them one by one. So add, we can add an item that does not exist, such as 0. So add returns a set. The set does not return anything. Let's look at. So it returns none because it modifies the S1 in place. Adds an element to an already existing set. Okay, so it mutates S1, doesn't return none, and this is the case where the item does not yet exist. If the item already exists, such as 3, it does not throw any errors, but it doesn't do anything because 3 is already in the set, and sets cannot have duplicated items. Then there's remove. Remove is similar, so returns none, but modifies S1 in place. And then it says if the element does not exist, it raises an exception of type key error. Okay, so 1, 2, 4, and 5, because the item 3 was found and removed. Let's remove the item -1. It fails, throws exception key error. If we do not care if the item exists or not, it should just try its best to remove it. Then we have the discard method. It says remove an item if it's a member, does not raise anything if it's missing. Okay, so it's like an error, like a remove method that doesn't throw. Okay, this was the case where the item did not exist. What if the item exists? It removes it. So the item now has just, the set has just 4 items now, 2, 3, 4, 5, because the item 1 was found and removed by the method set discard. Okay, let's look at pop. What does that thing do? Python, what's this? A set pop. Removes a random item from the set. I'm not sure that or yes, because they have no order. Elements, items inside of a set do not have any order. So instead of actually iterating through them, seeing what values are in the set and removing one in a random order, you can just go pop. Okay. And it returns the value that was removed from the set. Okay, so we can go print. First on line 2 we print the element that we removed from the list. Then on line 3 we print the remaining from the set. And then on line 3 we print the remaining set. So it removed the random item, which is the item 1. And then the set only has 4 integers. It's not that random because if I run it 100 times, it will always pop this first item. Okay, let's now look at the last method which we're going to look at, which is the one that removes all of the items from a set. So the set becomes empty. And now Python needs to print this S1 differently. Previously, it printed curly brackets and 1, 2, 3, 4, 5. Whereas if we clear, it doesn't print curly brackets, nothing curly bracket, but instead it says set and an empty pair of round parentheses. Okay, and now we're at sets, which is a type in Python. Exercise number 1. So says that we have 2 sets and we should join them. So let's see what we have. And the name of the new set should be my set 3. So in order to join 2 sets, we will use the union set mathematical operation. Okay. The PyCharm integrated development environment allows me to write MS2, so the first character in all of the words. So my set 2 has 3 words, my, set, and 2. And the first characters there are M for my, S for set, and 2. So if I write MS2 and I press the tab key on my keyboard, it will do the writing. Okay, we did not print my set 3. MS3, tab key, Shift F10. So what it did, it put all of the items of the 2 sets together, 1, 2, 3, 4, 3, 4, 5. And sets cannot contain duplicated items, and these 3 and these 3 were duplicated. So now the only items are 1, 2, 3, 4, 5, 4, and 5. But then the order is not guaranteed in sets. The next one, remove a random item from the following set. For that, we're going to use pop. So, dot pop. Okay, so this is popped. And we're going to print both the popped value and the local variable of type set. So it removes randomly the item Rachel, which we can see that was the first one, and then the rest of the items in the set remained in the set. Phoebe, Chandler, Monica, Ross, Joy. Okay, let's see if this is okay. And the third and final one is add the name Günther to the following set. So RAF dot, and we have add, and we should add Günther without the E. If F10 and print. Okay, so Rachel, Monica, Phoebe, Joey, Chandler, Ross, and then Günther in here. And this is okay. Let's now look at the Python type boolean. Let's declare a local variable b1 equals, and the boolean literals are either true with an uppercase T or false. And let's print both the type of b1 and the value of b1. Okay, so class bool, there's a built-in Python type for booleans, and false. When Python prints a value that's boolean, it will write these characters, either false or true with an uppercase F or an uppercase true. So the same as the value of the boolean literals. Okay, we talked before that Python is a case-sensitive programming language, so false is very different from false depending on the capitalization. So all lowercase characters FALSE false does not exist. This would be a variable that you need to declare first before using, whereas uppercase F and the rest lowercase ALSE is a Python keyword, is the false value of the bool type. Assignments to false are illegal and raise syntax error. So it's a keyword, reserved word. Another way of creating booleans, so the first one is to just use the boolean literals, so false or true. Another way to do it is to use the integer comparison operators. So you can have 4 less than 5 less than 4. Is 5 less than 4? So this would be false. And it is. And it's also a boolean. So the right hand side we're doing here on line 1 the declaration initialization of variable, local variable b1. This is the equals operator, and the right hand side is what follows the equals operator. The right hand side needs to be evaluated by Python in order to know how to declare and initialize the variable b1. So 5 less than 4 is an expression which with two operands and operator less than, greater than, so comparison operator. Comparison operator applied to two integer operands returns boolean type. So 5 less than 4 is going to be false. 5 greater than 4 is going to be true. 5 equals to 4 is going to be false. And we can have, for instance, an integer which is 3 plus 2. And let's see if 5 equals the num. And it is true. Okay, so on line 1, we declare a local variable that has the value of the right hand side. The right hand side is evaluated to 5, so num is 5. Then on line 2, we're declaring the local variable b1, there's the equal, and then there's the right hand side. The right hand side gets evaluated to 5 equals, and the value stored inside num is integer 5. So 5 equals to 5, this is true, boolean. So b1 is a boolean local variable with a value true, which we can see printed here. Okay. And we can also compare it like this. 5 is not less than 5, so boolean false. But 5 is less than or equal to 5, boolean true. And then we could not have this local variable declared, but instead in here have the expression 3 plus 2. Okay, so b1, we're declaring it, and the right hand side is 5 less than, and then a parenthesis. We need to compute the entire right hand side. So because we have parentheses, the operations inside of the parentheses have precedence, so we first need to evaluate the value of the parentheses. So the value of the parentheses is 3 plus 2. So binary, arithmetic, integer equal plus operator, two integer operands. So 3 plus 2 is integer 5. So the parenthesis is evaluated to integer 5. 5 less than integer 5, false. Okay. But then we can also remove the round parentheses because of this. I searched on Google for Python operator precedence table, took me to the official Python documentation, docs.python.org/reference/expression. And at chapter 6.17 operator precedence, we can see in which order operators are evaluated in Python. We need to know the order in which operators are evaluated if we want to delete parentheses. So if we keep enough parentheses such that we disambiguate and make it clear for everybody that we first need to evaluate this and only then this, we use parentheses. If we want to delete the parentheses, before actually deleting the parentheses, we'll need to look in the operator precedence table to make sure that plus is evaluated before less than. So the this is the table. It's in sorted order. And the sorting is highest precedence to lowest precedence. So we want to answer this question. Is mathematic addition, arithmetic plus operator with a higher precedence that comparison operator less than? Where is each of these two operators? So at this position is the minus, is the less than mathematical comparison operator, whereas plus addition is way above it. So that means that plus has better, higher precedence than less than. That's why Python knows that in this case, when we do not put parentheses, this right-hand side is an expression, has 3 operands and 2 operators. Which of the operators needs to be evaluated first? Plus. So Python first evaluates this, 3 plus 2 is 5, and then evaluates the operator with the lower precedence. So 5 less than 5, and that's false. Okay. Okay. So we looked at less than or equals, greater than, equals. There's also these two other possibilities, greater than or equal and not equal to. So let's see how not equal works. So 5 not equal, and then 2 plus 3. Shift F10 says that it's false. So 5 not equals to 5 is false because 5 is equal to 5. Okay. Then we can convert any boolean to bool. It's not needed because it's the same thing, but it's possible. So bool is the function that we use in order to convert something to the boolean type. The boolean type can be converted to boolean type. Okay, so 5 different than 5. 5 equals to 5. So it's exactly identical as if we do not put these characters B, O, O, L, and then a pair of parentheses. Okay. Then bool of nothing is false. Creates and returns a new object. Okay. Okay. As we see in the same row in the operator precedence table, we can also do in, not in, is, and is not. So let's try to do in. So we'll have a list 1, 2, 3, and 4, and we say is 1 in list, and it is, and it's true. So in returns a bool value, a value of boolean type. Okay, what about a value that does not exist? It will return false. Okay, then we have not in, which is this thing. We have not, which is a unary operator. So we can have if not false, and not of false is true. Next up are 3 exercises for boolean type. Make a comparison that returns a boolean and store the result in a variable called test. Variable is test, and we do a comparison. 5 less than 4, greater than 4. Great. And let's print it. It's true. 5 is greater than 4. Exercise number 2. We have a fraction and is greater than a multiplication. Okay. So we need to check if this is greater than this. And it's false. Why? Let's declare 2 variables. So what is this? v1 equals, and then v2 equals, and then we print the 2 variables. And we replace these things, or not, we don't need to. Okay, so the first is so slash is number division, which is not floor division, which returns a float. And this is the float that's returned, 524, and then some decimal places. Whereas 87 times 56 is the integer multiplication integer 4872. And 500 is less than 4000. So this thing is false. Okay, and that's correct. The last exercise, square root of 25 is equal to 5. And we use print. So print. We can print directly the result of the computation, like the square root of 25. That's 25 power 2 of 0.5, and then equals to 5. And it's true. Okay, so how does this work? Again, we need to look at the operator precedence table for the double multiplication, which is called exponentiation. So exponentiation has higher precedence than equals equals, which is equality comparison. So first this operator is evaluated and then this one. So we do 25 raised to the power of not 2, which would be 25 times 25, but raised to the power of 1 divided by 2. So 1 divided by 2 is 0.5. So that's the definition of square root. It's the number raised to the power of 1 divided by 2. So 1 divided by 2 is the power. Okay, and then some questions. What method should you use to find the fifth character within the string success stored in the variable myword? So the fifth character means index 6. The fifth character means index 4. Okay. What indexing parameter should you use when extracting a substring if you want to iterate through a string in reverse? If you want to iterate through a string in reverse, the indexing parameter should you handle when extracting a substring? Oh, the second parameter end. -2. I forgot this one. Yes, only step. The step could have been. So a negative value in the step inverts the direction in which we traverse the string. What does it mean for a method to act in place? That it transforms an object without returning a result. Correct? If we have the values true, false, none, booleans can assume the following values. True, false, none. No, the booleans have just two values, true or false. Which of the following objects would not be supported by a set? So all of the items inside of the set need to be immutable. So you cannot say item square parentheses 0 and then assign it a value, which you can do for lists, you cannot do for strings. You cannot do for tuples, you can not do for float literals, and you cannot do for integers. So not supported by a set are lists. What does sort return for the list with 4 string values? So sort is mutating the list in place and returns nothing. Which of the following logical operators means different than? That's exclamation mark and then equals. Okay, next up we will do a project, so a Python program that runs at the command line that asks the user for a long text, so a book paragraph, and then asks the user to provide 3 characters, so 3 letters, and then it will print. The first letter appears 3 times, the second letter appears 10 times, the third letter appears 0 times. So let's see how we do that. So you want to do input with some text. Please provide a long text. This will be input text with underscore. which will print. And then we'll ask for 3. So let's see. This would be the text. This would be 3 characters. One. Character 1. And we'll modify this one because we want to keep just the first character. So we're going to do trim. How do we do trim? Strip. Thing. And then we want to keep just the first item. The same for the rest of the characters. Okay, and then we'll print everything just to make sure we are working with the correct data. ch1, ch2, ch3, if F10. Now we need to click into the Run Alt F4 tool window, otherwise we cannot input text. So long text is here written in the color green. I press the enter key. Now we're at line 4 where it says character 1. We're going to write a uppercase A. Character 2, we're going to write a WE. And character 3, we're going to write a QA. Okay, so this is the input text is correct. Then there's a space, which is this, comma, and then character 1, which is uppercase A, and then character 2 is just the first character, W, and character 3 is just the first character, which is Q. Okay, we'll pass this hurdle now. Let's compute how many times does the letter A appear. So the first character. So for that we go input, text. I remember the name of the method, so it was a method and it was called count. Has 3 parameters: what to count, where the index where to start, and the index where to end. Okay, we want to start at index 0, go to the end. So we do not want to specify the second and third parameters, but we want to specify the first one, which is of type string. And that would be ch1. Okay. What does count return? It returns an integer, which we want to store and print. Count of ch1. The same thing we want to do for the other 2 characters. Okay, we want to print these counts. So count of C1, count of C2, COC3, up. Shift F10, press, clicking after, please provide the long text. ELE. Okay, so P appears just once, not twice. That's a problem. So we need to count how many times the character P appears, not how many times the uppercase P appears. So count is case sensitive. It has found just one uppercase P, this one. Whereas L, it has found 1, 2, and this is the count, 2. E appears multiple times, 1, 2, 3, 4, and we print it in here. Okay, let's make this print a bit easier to read. So you want to say count of one is okay. Let's actually use the print because it's going to be easier. What was the syntax? Okay, so we end the string here. This is character 3. This is character 2. And ends with a dot. Space in here and in here. Okay, let's run it. This is single quote. Okay, let's provide the long text. E, L, E. So count of uppercase P is 1, count of L is 2, count of E is 4. But again, we do not want to count. So the count should be case insensitive. That's why we'll need to have lowercase values read from the keyboard, at least for the characters. So let's go with lowercase. Okay, let's run this thing. Shift F10. Control V. E, L, E. Okay, so L is found twice, here and here. E is all lowercase already, but then P was not found on this position because we're converting the uppercase P to lowercase p, and it found it in here. So this is wrong. We should lowercase also the string that we're searching for, which we do, but also the string we search into. Okay, let's lowercase it immediately after we read it. Like this. See if it's enough. So uppercase P, L, and E. And now count of P is 2. So it lowercase is this text, it lowercase is this uppercase p, and it finds the lowercase p in here and in here. So it's 2. So we finished with the first requirement and we have 4 more requirements to go. Okay. Then we need to compute the number of words in the input text. So we do that like input text is a string. We want to convert it to a list. We want the list not to include spaces. And we want to split the string by spaces, by the white space separators. So we have a split method. And if we do not provide any separator, what does it happen? If we do not provide a separator, the split will happen on any white space. So \n, \r, \t, \f, spaces and other things which are white space. Will not return empty string. So if you have 2 spaces, those will be discarded, but then the nothingness between them will not be returned as the empty string, which is exactly what we want. Okay, so this is a string. The return from split is a list of strings. So this would be named words list, and we'll print the size of it. So the list contains just words, and we want to know its length. Okay, so please provide a long text, and then this space was removed because it's white space. So splitting was correct. And then there's 1, 2, 3, 4, 5 words. And then the count is 5. So let's keep just the len displayed. Now we need to compute the first and last letter in input text. So we'll do that straight in a side of the print. So that would be input text. First character is always at index 0. The last character in the string is always at index -1. Okay, so 5 words, and then the first and last are these. We'll need to make the printing more verbose because we do not know what this 5 represents. So let's use format strings. Count of words is. Okay, and then the same thing here. First character is this one. Last character is this one. Shift F10. Control V. ELE. And now it says count of P, count of L, count of E, count of words is 5, first character is P, last character is E. This was part of the previous debugging that we did, so we wanted to know that the input text was read correctly and then the characters 1, 2, 3 were read correctly. So we actually do not want to print these internal details, which will improve the way the output of the product of the program is. So this is text that's meant for the end user, whereas this is text that's meant for the programmer. These 3 lines are also meant for the end user. So let's keep in the output of the program just lines that are meant for users of the program. Next up, we'll need to compute the number of words in inverted order. So we need to print the words in inverted order. So we'll kind of reverse the input text. And then we should write if the word Python exists in the text. Okay. So in order not to enter this text, which is really long and complicated to input and makes testing the product really slow, we'll replace it in here just for testing purposes. Okay, equals, and then we'll have some text with Python. Some really long text with Python thrown in. Okay. Let's run it and see if now we can run faster the application. So it does not matter what we type in here, we can immediately press enter. Character 1, P, Y, and T. So Python appears once. Python. So it could not find P because we did not make it lowercase. Okay. So let's fix this in a better way. Input text is input text dot lower. Okay, so we cannot change the characters inside of a string because the string is immutable. The string has on position 0 uppercase S. When we go lowercase, we would want to edit the character at position 0 to replace it from uppercase S to lowercase s, but we cannot. So that means that lower cannot change input text, which means that lower is forced to return a value, and that value is the string lowercase, and that's the right hand side. so a all lowercase string, some really long text with Python thrown in it. And that's assigned to on line 5 to input text. So I press enter here and then some random characters, and the count of P is 1 because it's in here. And now it's actually useful to print the input text, which I should do. Let's do it in here. Let's go with double quotes. The text is and we'll enclose it in single quotes. IT top. Okay. Shift F10. So I press enter here. The text is some really long text with Python thrown in it, all lowercase, great. P, Y, and T. P appears once here. Y appears in Python and in really. And T appears in many places. Once, twice, 3 times, 4 times, 5 times. Okay. So we should take all of the words which we have in this list, and we should reverse the list. So reversed words list. I don't know, can't we use this trick? Opa, where are we? Once. PYT. And the order is correct for the word. So in, thrown, Python, release on. So this is the trick with -1 as step. So we do not say from which index to start. We do not say to at which index to end, which means it should include the first character, it should include the last character and all of the characters between. But then step -1 means write one, skip one, write one, skip one, but in reverse order. So it's actually returns a list in the reverse order. Or maybe there's a method for this thing. Dot reverse. This returns none because it reverses in place. Okay, so let's use this notation for this time. And it says that we should convert this list to text. So we should print the words in reversed order, but not as a list, but as prose. So that would be reverse words list dot join. There's no such method on the list, but it is on the strings. I'm not sure what's the syntax. Concatenate any number of strings. The strings whose method is called is inserted in between each given string. So if you want to go ab dot, you should go dot as a string dot join, which is exactly what we should do. So we use space as the separated for the joined words. Okay, and the last requirement is the Python word there? So that would be print. Let's create a boolean variable. Exists Python equals. We have the words list and we need Python. So Python in words list as boolean, and then we print it nicely. So in here we need to print the words in reverse order, and in here we'll say if Python exists or not. It is true or false that the word Python exists in the text. Okay, so P, Y, and T. And then it is true that the word Python exists in the text. In is a word. Oh, yeah, this is the words in reverse order, correct? And then the first character is S, the last is dot, which is true, because the given text ends with this dot after the word in. So everything seems okay. Next up is the comparison operators. These are binary operators, or have two operands, and return boolean type. So let's first look at the difference between equals and equals equals, to double equals. This is the assignment operator, whereas this is the comparison operator equality. Let's see how they work. So using the first one, which is the assignment, we can say that we have a variable equals 5. Let's print the type. And the value. Okay, so my variable was never declared before. So this assignment operation is actually where my variable is declared. So this is both a declaration and an assignment. And then the right-hand side, the parts that are after the equal sign, are the right-hand side is evaluated to the value integer number 5. That's why my var variable is created, declared, and the type for now for the variable my var is going to be class int, and the value stored inside of the variable is 5. Okay. Then we might have more complicated right-hand sides that actually use comparison operator equality. So let's see if 5 equals to 3. Okay, so the variable myvar was not declared before. It's declared on line 4. The right hand side is 5 equals comparison operator equality 3, which is 5 is not equal to 3. Comparison operators return boolean values, either true or false. So 5 equality 3 returns false, and then inside of the variable myvar is stored false, and the type of myvar is class bool. Okay, let's see how we can use the equality operator to generate a true. We can say 5 equals to 5. It returns true, boolean. This right hand side is complicated already. There's a comparison operator and 2 operands, but we can make it even more complicated than that. We can go 1 plus 2 times 2, and it's still true. Why? Because we have this operator precedence table where it says that assignment has the least priority, so this thing will be evaluated. So this has priority with what? Priority 1. This equality has priority 1, 2, 3, 4, 5, 6, 7. Plus is 8, 9, 10, 11, 12. And multiplication is this one, so 13. The operations are evaluated in the order of precedence. So the higher precedence goes first. So first goes 2 times 2, which is evaluated to 4. Then 13. Then the operator plus, which has priority 12. So that's 1 plus 4. That's 5. And then comparison operator equality, which says 5 equals to 5. And then at the very last, it's the assignment expression, which is this equals. So my var receives the value 5 equals 5, which is actually true, bool. Yeah, we can go even more complicated than that. We can have in here a 10 minus 5. And it's still true because, let's see how that looks like. So this is 1, this is 7, 12, 13, and then minus is the same thing as plus, so it's 12. Okay. So we first do 13, which means 2 times 2 is 4. Then we do 12, which means 1 plus 4 is 5. Then we do 12, which means 10 minus 5 is 5. And now we're at the position where we compare 5, compare it, comparison operator equality, and then another 5. So this will be true with uppercase T. And it's still true. Okay, so equality comparison operator works on integers, but can also work on strings. So we can go John equals to Mary. and John is not equal to Mary. So John equals to Mary returns false, boolean. In Python, string comparison is case sensitive, which is the good thing. Okay, so we can compare, for instance, lowercase John with uppercase John. And the result is false. In order to compare case insensitively, one of the things that we can do is to lowercase or uppercase both operands of the equality comparison operator. And now it's true. Yeah, we can see that John is all lowercase, so there's no need to make it lower again. But sometimes we just do not know the value of the operands. Those might be, for instance, a local variable. So it's a good practice to lower both operands of the equality operator. Okay, then values might seem similar, but they are different. For instance, the string 100 is different from the number 100. But then floats can be compared with integers, and 100.0 is equal to 100. This was the equality comparison operator. Now we're at the next one, which is inequality. So exclamation mark and then equals. So 100 float is equal to 100 float. They're totally not different. So it returns false. But then if we put any other value on the right operand, for instance, 23, then yes, 100 is different from 23, returns boolean true. Okay, next up, the less than and greater than operators. So 100 is not less than 23, false. 100 is greater than 23, true. And then we also have less than equals and greater than equals. So if we compare 4 less than 4, we get false, whereas less than equals, 4 less than equals to 4, then that's true. And the same thing for greater than or equals. Okay, next up, there's 3 practice exercises for comparison operators. Says that we have 2 variables, one named num1 and the other one named num2. And the values are 36 and 17. And then we should create another local variable named myBool that stores the value if num1 is greater than or equal to num2. Num1 greater than or equal to num2. Okay, let's print this thing to make sure it's actually true. Print type mb and then shift F10. So it says true because 36 is greater than or equals to 17. Okay, next one. Create 2 variables num1 and num2. Inside num1 store the result of the square root of 25. So that's 25 to the power of 0.5. And then inside num2, store the number 5. Okay. Check if num1 is equal to num2 and store the results in the variable myBool. So 25 to the power of 1 divided by 2 is square root of 25. 5 times 5 is 5 to the power of 2, and it's 25. So square root of 25 is 5. Num2 is 5. This is 5. This is 5. And then 5 equals to 5 is true. And the final one, two local variables, num1 and num2. Inside num1, put the result of 64 times 3. Times 3. Inside num2, store the result of 24 times 8. Check if num1 is different from num2, store the result in the variable myBool. So num1 should be different than num2. Let's actually print these. Num1, num2. So num1 is 192, num2 is 192. And they're definitely not different because they're identical. So it returns class bool false for the variable myBool. Next up are the logical operators. They do not have the same precedence order. So not is a unary operator, has just one operand, not and then the operand. Has higher priority than AND, which is a binary operator, so has two operands, left and right one. And then OR has even less priority than that. Let's see them in action. So we can have the my variable equals to, and we want to compare if the number 10 is greater than 5 and if 10 is greater than 10 at the same, and then 15 at the same time. So that would be 5 less than 10 and 10 greater than 15. And then we do the same thing as we did before, which is print type shift F10. Okay, so let's see this complicated right-hand side, which has 3 operations and 4 operands. So how Python evaluates them. So again, one for assignment expression, the least priority possible. Then for less than 7. For AND 5. And for greater than another 7. Okay. This would be very explicit if we actually put round parentheses around simpler operations. So this is one expression, this is another expression, and this is another expression. By using round parentheses, we make it apparent and evident what is the order in which the 3 expressions are computed. We do not need to use round parentheses. We can use them. It makes everything more readable, but it's not mandatory because fortunately this time the priority of the expressions is such that this expression is evaluated in an identical way to this expression. Because the comparison operators have priority 7, whereas AND has priority 5, so the less than and greater than operators have greater priority than AND. Okay, let's see how things get evaluated. First of all, this expression gets evaluated, so 5 less than 10 is true. Then this expression is evaluated, which means 10 greater than 15, which is false. And then the AND is evaluated, so true and false. AND returns true only if both operands are true. So this is true, which is great. The left operand of the operation or of the operation AND is true, but then the right operand is false, which means AND will return false, which we can see in here. So let's do the table. How did we do it? X, Y, and then X and Y. Okay, so this is the table of the Boolean operator AND. So if X is true and Y is true, X and Y is true and true is true. If X is true and Y is false, X and Y is false. If in any other combination, X and Y is false. Okay, so X and Y is true in just one combination, when both its operands are true. Okay, for instance, we might have the left operand 5 less than 10, that's true, and then the right operand, which does 10 equals to 5 plus 5. And that's indeed true, because the left operand is true, the right operand is true also for the operator Boolean AND. Okay, so the two operands of the operator AND are of type Boolean, so we can have anything that can be evaluated to Boolean in the two operands. You can have even comparisons of different types. So this is comparison of numbers, whereas in here you might have comparison of strings. It's still true because string 1 is different than string 2. Okay, this time is false because the left operand is true, this case. The right operand is false because comparison equality operator, has detected that here is a lowercase s and in here there's an uppercase s. So this returns false. We're on this case. True, false, and then end will return false. Whereas now it will return true because string 1 is equal to string 1 dot lower. And then we're in this case. Next up is the operator OR. So let's compare, for instance, that 10 equals to 10 and 5 equals to 5. So this is a different Boolean operator, not AND, but OR. They have different priority order, AND and OR, and they have a different table. Let's look at the table first. So if X is true, Y is true, then X or Y is true. In fact, the only place where X or Y returns false is if both X and Y have the value false. Okay, so this is the table of the operator OR. If X is true, does not matter what the value of Y is, X or Y will be true. If Y is true, does not matter the value of X, X or Y will be true. So if Y is true, or Y is true, does not matter if X is false or true, X or Y will be true. The only possibility where X or Y is false is if both X and Y are false. So let's see that. Ten is not equal to 1, so this evaluates to Boolean false. So X is false. But then 5 equals to 5 evaluates to Boolean true, and then Y is true. So we're in this case. So false or true equals true. We can see the output in the console. Okay, so we might have 5 equals to 50, and then X, so the left operand of Boolean operator OR, is evaluated to Boolean false. The right operand is evaluated to Boolean false, so both are false, both X and Y are false, then OR will return false, which we see here. Okay, next up, let's look at the in membership test. Okay, so we have a text. This is some random text. Okay, and we'll use the in operator. So we'll ask, is text in text? And it is. Text is here inside of the text. This is the operator that we used. And we want to have a more complex Boolean expression here. So we can say things like and random in text. And this is true. How do we see that? We go clear all and then rerun. So it's true because a random exists in the variable text at this position. Text exists in the string variable text at this position. So both this is true and this is true. And then, because we did not use round parentheses, we're at the mercy of the operator precedence table. So let's actually look in which order this complicated expression is evaluated. So we have in, which has priority 7, and which has priority 5. So again, 1, this is 7, this is 5, and this is 7 again. Okay, so the order in which the right-hand side is evaluated is this expression is evaluated first, this expression is evaluated second, and then the results of the left and right operand of AND are used to evaluate AND. So text in text is true, a random in text is true. The only way to have the operator AND return true is if both its operands are true, which is the case now. In order to make everything more explicit, we could have used round parentheses. Like this. Okay. If one of the operands of AND is boolean false, AND will return false. So we can search for a string that does not exist in the variable text. For instance, we're going to look for the moon. Moon does not exist. This is boolean false. Text exists. This is boolean true. True and false is false. But then if we use the boolean operator OR, the result will be true because only one of the operands needs to be true, which this is true. This does not even matter what value it has. And there are programming languages that don't even evaluate this thing, which is called short-circuiting evaluation. So if you have an OR and its left operand is true, then you don't even evaluate the right operand of OR. It's enough. Next up is this boolean not operator. Unary has just one operand. So let's see how that looks like. We can compare that text equals to text and it's boolean true, but then we can negate this entire thing by using the boolean operator not. So not has just one operand, the right operand. Let's look at the order in which the operators are evaluated. So not has priority 6. And equality has 7. Okay, so how does the right-hand side expression get evaluated? The higher the priority gets evaluated first, so equality gets evaluated first, this thing. Text is a string, and equality comparison operator equals says that it's true, because text equals to text. So this entire expression gets evaluated first and gets evaluated to the boolean value true. And then we go not true, and not true is false. Let's look at the table of not. So there's x, there's not x, and the possible values of x are true and false, and the result not true is false, not false is true. Okay, so this is true. We're in this case where x is true. And then not x is false. This is false. This is boolean false. We can see it in here. Okay, and then this case where x is false, we can go like this, for instance. X text is different from text. No, it's identical. So this returns boolean false. And then boolean false negated is boolean true, which we can see in here and here. So we can clear and rerun. Okay, and now we have 3 exercises for practicing logical operators. It says create 3 variables num1, num2, num3. Num1, num2, num3. Inside num1 store the value 36. Inside num2 store the result of the operation 72 divided by 2. So this is a floating point division, is not an integer floor division. Inside num3 we have the value 48. Okay, so 72 divided by 2 is 36. Check if num1 greater than 2 and less than num3. Store the result in a variable named myBool. Okay, so let's see. Check if num1 is greater than num2. We'll use as many round parentheses as possible. Num1 greater than num2. So num1 greater than num2, no, they're identical. And less than num3. So that's going to be and less than num3. So I understand that num1 is less than num3. Let's read again. Check if num1 is greater than num2 and less than num3. That's how I understand it. Create 3 variables, num1, num2, num3. Inside num1 store 36. Inside num2 store the result of 72 divided by 2. Inside num3 store the value 48. Check if num1 is greater than num2 or less than 3. So num1 is 36 is less than num3, which is 48. So this is evaluated to true. There's no need for us to evaluate the left operand of operator OR. If the right operand is true, then OR will return true. So clear and go. Okay, next up, we have 2 words, word 1 and word 2. check if the words word1 and word2 are not found in the sentence given. Okay. In a variable myBool. In the sentence below. So this is probably named sentence. I do not like the left-right scroll bar. So I enable word wrap usually in the integrated development environment or in the text editor that I use. And then it says declare a variable named myBool, which will certainly need to print. Okay, so let's see what we have in myBool. Check if the words word1 and word2 are not found in the sentence. We could use negation, or we could use not in. So let's go with not in first. So word1, not in sentence. We'll use as many round parentheses as possible. And word2, not in sentence. So success is not in the sentence. Technology is not in the sentence. So this should print true. And it does. And it's successful. So all of our Python programs, all of the Python source code that we wrote up until now was in a sequential structure. So the line 1 was interpreted, then line 2 was interpreted if there was a comment that was skipped by Python, and then the next line is interpreted. So all of the lines are interpreted top to bottom. That's the sequential structure. Now we have a different structure than the sequential one, which is the alternative structures, the decisions, if, however you want to call this thing. So evaluation might skip large number of lines of source code. Let's see how. For instance, we have if, which is the keyword that we're going to use. We say if 20 greater than 10, then we must put a colon, and then we must indent. So this indentation is 4 spaces. Our integrated development environment PyCharm puts the indentation automatically. If your text editor does not indent by automatically, you should put 4 spaces. Okay, let's see, print success. A new line, and then we run. Where are you? This guy. Success. Okay, let's see how some lines of Python source code are not interpreted at all is when we have the else block of the same if, where we say print failure. we are done with the alternative structure and we are back in a sequential. Okay, so this is a sequential structure. This is an alternative structure. Together, they form a sequential structure. It's alternative because either this block of lines is executed or this block of lines is executed. So this other block, lines 6, 7, and 8, is the else block. Okay, so let's see how it does. It says if, and then a boolean condition, and then colon. This line 1, is interpreted first, is executed first by the Python interpreter. So this is the boolean condition, which is comparison 20 greater than 10 returns boolean true. This is true. If this is true, then the then block is executed. If this is false, then the else block is executed. There's no possibility of executing the then block and then the else block, or the else block and then the then block. Only one of these two blocks will be executed, either lines 2, 3, 4, which is the then block, or lines 6, 7, 8, which is the else block. So let's see in here, it says we are in the then block, so line 2 was executed. Says success, then line 3 was executed. The then block has finished, line 4 has executed, so these are all three lines which were printed by the body of the then block. And then line 10, line 9 is executed, but it's empty. So after the then block finishes, the else block is ignored. Line 9 is executed, nothing happens because the line 9 is empty. Line 10 is executed, which prints this. Line 11 is executed, prints this. Line 12 is empty, and then the entire process finishes with success, exit status 0. Okay, so it's alternative structure because only the then block is executed or only the else block is executed, depending on what the value of the Boolean expression that's between if and colon is. In this case, the Boolean expression is true, then branch is executed. If we say is 20 less than 10, no, 20 is not less than 10. This is Boolean expression false. The else block is going to be executed. The then block is going to be ignored. So to the console, the following things will be printed. We are in the else block, failure, the else block has finished, we are done, done. We are in the else block, failure, the else block has finished, we are done, done. Of course, this Boolean expression can be as complicated or as simple as possible. Could be just a Boolean literal, it's going to work. could be, as we had before, a comparison, could be a simple boolean variable. So boolean variable with the value t in text. Okay, so t in text is boolean true. This is boolean true. This is boolean true. The if will execute the then block, which we see executed in here. And then after, this is the if statement that finishes, and then all of the lines after the if block will be executed one by one, because this is a sequential structure, which we see in here. The two lines were executed. Okay, next up, let's look at pets. So we have a pet, which is a dog, and then we'll see what type of pet is this one. So if pet equals to cat, don't forget the colon, don't forget the indentation. This we're inside of the then block. Print, you have a cat. And on the else block, we'll have unknown pet. And we are not inside of the else block anymore, so we can delete this indentation. Okay, so indentation is used to signify if we're inside a block or not. In this case, if you want to put more sentences, more Python source code lines inside of the then block, you need to press enter, make sure that this indentation, which is 4 spaces, is identical to the indentation of the other source code lines from the then block. So it's 4 here on line 4, 4 spaces on line 5, which is correct. And now you can add more source code lines. The same thing for the else block. If you want to put another Python source code line in the else block, you need to make sure that the indentation 1, 2, 3, 4 is identical to the indentation of the rest of the lines of the Python source code lines inside of the else block. Okay, so pay attention to the indentation. Line 9 is not in the else block because there's no 4 spaces indentation, whereas line 8 is because it has the same indentation as lines 6 and 7, which are part of the else block. Okay, so unknown pet, because pet is a string variable, has value dog. This is a Boolean comparison operator. Pet equals to cat, no, because dog is not equal to cat. The then block will not be executed. The else block will be executed in its entirety. So first line 6, then line 3, and then line 8. Okay. Okay. Why did the variable pet have the value dog and then we compared with cat? Because we actually want to do a determinator, right? We want to determine what type of pet you have. The case where none of the conditions are true, the else branch, the else block will say unknown pet, but then we will have more then blocks than this one for cat. We will have one for dogs, another for fish, trees, etc. So let's put another condition, this time for a dog. You have a dog. And another one for a fish. Okay, so let's look here. This is the else block. This is the then block of the condition pet equals to cat. This is the then block of the condition pet equals to dog. This is the then block of the condition pet equals to fish. Python will execute only one block, will ignore the rest. So there's no possibility of executing this block and then this block, or this block and then this block. This is an alternative structure, which means does not matter how many blocks it defines, only one will be executed. Okay, how does evaluation run? Runs on line 1. Line 1 is evaluated, pet equals to dog, so a local variable of type string is declared, named pet with the content dog. Then line 3 is executed, says pet equals to cat, false. Then this is not evaluated. This line 4, so the body of the then block for pet equals to cat. Then the next condition is evaluated, else if pet equals to dog. Yes, dog equals to dog, so the then block for dog will be executed, has just one line, line 6. We can see it printed here. Then this condition is not evaluated, this else is not evaluated. So lines 7 through 10 will be ignored by Python. Python will jump straight to line 11, which is empty, the final line, source code line, and then execution finishes with exit status 0, which is success. So the order in which things are evaluated is line 1, line 2, line 3, line 5, line 6, line 11, and that's it. And we can see that using the debugger. So let's debug. So here at line 1 says here line 1. Step over. It saw that line 2 is empty, so it skipped over it. So it executes line 3 right now. So pet equals to cat, which is false. Then it will execute line 5. Okay. Line 5 says pet equals to dog, dog equals to dog. It will execute next line 6. I'm going to press the step over F8 button and line 6 will get executed. I'm going to press the step over F8 button and line 11 will be executed, which is empty, which will end the program. Okay, let's see the else block executed, the line 10. We'll have in here a frog. We'll run it in the debugger. So step over, line 3 executed, line 5 executed, line 7 executed, line 9 executed, line 10 executed, line 11, and the program stops. So it did this, 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 this. None of the conditions yet were true, which means it will execute the else block because it sees the else statement. So it executed line 10, which wrote unknown pet to the console, and then that's it, the program has stopped. Okay, so this, in other programming languages, you do not have the else if statement. You probably have else, and then you immediately put an if in here. This is the way the alternative statement, the alternative structure if. This is its syntax in the Python programming language: if, elif, else. Do not forget about indenting blocks. Do not forget about the colon. But we can put more alternative structures inside alternative structures. So inside of this branch, for instance, we might have another if, elif, elif, else. And inside of one of the then blocks, we might have another if, and etc. We might have 100 ifs nested one inside of each other. Let's see such an example. So we have age equals to 16 and grade equals to 9. And we'll have a first alternative statement. So if age less than 18, so he might be a minor, not an adult. On the else block, we know that the age is 18 or greater, so might be an adult. Let's see how this thing runs. Is a minor because in this case our Python program considers all persons with less than 18 years of age to be minors. So how execution runs is age equals to 16 line 1, line 2 grade equals to 9. If age less than 18, print minor, and then else is not executed, print is not executed, and then the program finishes. We can see in the debugger this thing. Step over, line 2, line 4, line 5, and that's it. Okay, this grade is in fact a school grade. If it's an adult, maybe the person is not in school anymore. If it's a minor, we'll do another alternative structure, another if statement for evaluating the school grades. So we have if school grade greater than 4. What's the thing? Greater than 4.5. Like this. It might be a float. Print array past. Okay. Else means the school grade is 4.5 or less. 4.5 is okay, so we need to go 4.4. Else. And on the else block, we have print you will repeat your school year. Hurrah. Okay. So age less than 18, it's 16. School grade is equal, which is a good grade. And you will repeat you hooray passed. Let's see how the debugger shows us how the Python interpreter interprets the source code lines. So line 1, line 2, line 4, 16 is less than 18, so line 5, the entire block. So this is the then block, and this is the else block. So the entire then block is next. So we're at line 5. then line 6, and we're in an if structure embedded in another if structure. So in the then block of the top level if structure, so this is the top level if structure, in the then block of the top level if structure, there's another if structure starting at lines 6 through 9. And now we're going to evaluate the deeper embedded if statement. So this one from lines 6 through 9 says school grade greater than or equal to 4.4, which is true. So the then block of the second if statement will be executed, so just line 7. So step over should be line 7. Then else is not interpreted. Line 9 is not interpreted, so all of these two lines, 8 and 9, are not interpreted. Else is not interpreted because it interpreted the then block of the top level if, so lines 5 through 9. The else body will not be the else block will not be evaluated, and then line 12, which is the final, the process will stop. So line 7, and now it will stop the execution. That's it. So in this condition, in this case, where we have two if statements, one embedded in the other, we need to pay extra attention to indentation. So 4 spaces, 4 spaces, 4 spaces, 4 spaces, 4 spaces means that the block from lines 5 through 9 is in fact the then block of the outer if statement. Whereas additional indentation, 4 spaces, is for the then block of the embedded if, and these extra 4 spaces are for the else block of the embedded if. Okay, so this 1, 2, 3, 4 are from this block, and these 1, 2, 3, 4 spaces are from this block. Okay, so this is a block, this is a block, this is a block, and this is a block. And then this, the entire thing is a sequential structure. This is an alternative structure, and this is a sequential structure. This is a sequential structure. This is an alternative structure. This is a sequential structure, and this is a sequential structure. So we have inside of a sequential structure an alternative structure. Inside the alternative structures then block we have a sequential structure, and then we have an alternative structure and a sequential structure inside the then block of the embedded if. Next up, we have exercises for the alternative structure for decision making for if. We have this source code, and it says using the variables num1 and num2, which are fed with user input. So the user enters data at the console, at the terminal. Create a flow control structure, so an if statement or more, that compares the values of the variables and returns a result according to the case. Let's copy the case. How do we do that? With triple double quotes. Okay. You must display the value of the user input instead of num1 and num2. Okay, let's see. So the outputs could be num1 is greater than num2, num2 is greater than num1, num1 and num2 are equal. Okay, I understand what it tries to do. Okay, so we have two numbers. Let's see the program running. Enter a number 12, enter another number 11. And then it should say num2, num1 is greater than num2, but using string format. Okay, so this thing. If condition num1 greater than num2, colon, we're inside of the then block. In here we need to just print, and we print what we pasted. So we print what we copied. F num1 is greater than num2. Says you must display the value of the user input instead of num1 and num2, which is what we did. Let's run this thing. So we enter 12 and then 11 and says that 12 is greater than 11. Okay. We have other possibilities where it says num2 is greater than num1. So that will be an elif. There's no possibility such that both num1 is greater than num2 and num2 is greater than num1. So that's why we use elif. Num2 is greater than, let's do it exactly how they do it in here. Or not. No, like this. Okay, so num2 is greater than num1 is the same thing as num1 is less than num2. Does not matter if we write it like this or if we write it in reverse, which would be num2 greater than num1. Okay, we should print num2 greater than num1, and then we have num1 and num2 are equal, which is the else block. Else, and then don't forget the colon. Num1 and num2 are equal. We need to pay special attention to spaces when we print, because otherwise the program that we write is not going to be identical to the program that we're expected to write. So if we don't put a space in here, our program will not respect the requirements of the program. Okay, let's run this thing. So enter a number 100, another number, and it says that what doesn't it like? It casted the string 100.0 to int, and that failed. So we must not provide floats when we enter data. So we should only enter integer numbers. Might be negative or positive. So let's go with -1 and -1. And says -1 and -1 are equal. Let's look at with the debugger. So we're at line 1. We should enter a number which is -1. Then we're at line 2. We should enter another number, -2. And then line 4 is going to be executed, which says condition boolean numeric comparison -2 greater than -1, which is false. So the body of then will not be executed. Then elif will be executed. Says -1 num1 is -1, num2 is -2, and -1 is greater than -2. So the then block will be executed, and the rest of the else alternative structure will be ignored. It will jump to line 10 and finish. So line 5, and then the process will finish. -1 is greater than -2. Correct. Let's debug it one more time. Step over. We need to enter two numbers. We'll go with the else block, so 100 and step over, and then 100, and then it executes line 4. 100 is not greater than 100 because it's equal. It jumps at line 6. 100 is not less than 100 because they're identical. It will jump to line 8, which is else, then line 9, execute the entire body of the else, so the entire else body, else block, and then line 10, and then the process will finish. This will write that the two numbers which are 100 are equal, so 100 and 100 are equal, and then exit successfully. Okay, then we're at the second exercise. We're given these data to work with, and the requirements follow. The laws of a certain country establish that an adult can drive if they are of legal age 18 years or older and have a driver's license. Create a conditional structure to check if a 16-year-old without a license can drive, and display the corresponding result on the screen from you can drive, you can't drive yet, you must be 18 years old and have a license, you can't drive, you need to have a license. Use the codebase already provided to set up the appropriate control structure and check those conditions. So you can drive means adult plus has license. You can't drive, you need to have a license means adult but no license. You can't drive yet, you must be 18 years old and have a license. Means that the person is a minor. That's how I understand it. So if it's minor, age less than strictly 18, then we need to print you can drive, you must be 18. Okay. On the else block, this is an adult. We'll put a comment here. And adults can only drive if they have a license. So if not has license, cannot drive because you don't have a license. Okay, and the else block is the happy one. Okay, so this is one way of do it. Handle all of the non-happy paths. So if age less than 18, you do that in an if statement. No license key, you do it in a if statement, and a then block. So then block, and then just the happy path in one of the else blocks. This is one way of doing it. Maybe you can force all of these things inside of a if, else statement. You might not need to have two if statements, one embedded inside of each other. Okay, so you can't drive yet, you must be 18 years old and have a license. Both does not have a license and age 16. Then age 19 should say that doesn't have a license. And then if this also true, age 19 has license, is the happy path line 11. Let's see how the debugger does it. So line 19, line 1, line 2, line 4, line 6, 8, line 10, 11, and the process finishes. No, it evaluates the multi-line comment. Okay, so how it was in the requirements, it was 16 and has license false. Okay. And the final exercise, number 3. Let's make this smaller. Speak French, knows Python, you meet the requirements, you need to know how to program in Python and speak French, you need to speak French, you need to know how to program in Python. Okay, let's read the requirements. To access a certain job, the candidate must be able to program in Python, both to program in Python and to speak French. Create a conditional structure to evaluate a candidate given these conditions and display the corresponding message on screen. You meet the requirements to apply. To apply, you need to know how to program in Python and speak French. To apply, you need to speak French. To apply, you need to know how to program in Python. Use the code already provided to set appropriate flow control structure and check those conditions. Evaluate a candidate who knows French but does not know how to program in Python. So evaluate a candidate who knows French, so speak French true, but does not know how to program in Python, knows Python false. Okay, so this is going to be more readable if we'll do it in with two if statements than if we do it with if else if. Let's try with an if else if though. So if you meet the requirements to apply, which means speak French and knows Python. So this is the happy path. Then else if this person knows both is handled by the then block, and that's it. Whereas the rest of the persons do not meet the happy path. To apply, you need to know both this and that. Okay. Else if not speak French, print this. Elif not Python, then print okay, and the else statement is going to be the longer one. Depends on what the actual requirements are, but the existing requirements can be interpreted as such. So you can interpret the requirements either that just one line should be printed, or either one line should be printed, or 2 lines, or 2 lines. So in the case the happy path, just one line, but in the case not speak French, we should print both this one and this one. So we'll see what was the intention with the requirements. Okay, as it is right now, we will obviously print just one line, because either this block is executed, either this block, or this block, or this block. So this is the else block, this is the then block of line 8, this is the then block of line 6, and this is the then block of line 4. Let's see with the debugger. So line 4, line 1, line 2, line 4, and then doesn't speak French, so line 6, then knows Python false, line 8, and then this condition is actually the first one to be true. Not knows Python, not false is true. So the block, the then block of line 8 will be executed. So line 9 will be executed. Then the alternative structure, the if, will finish. This means that line 12 will be executed. So line 12 and 13, and then the program will exit. Okay, so this was correct, the correct implementation of the exercise number 3. Next up is the repetitive structure. So we had sequential structure, alternative structure. Let's write them down. And now we have repetitive structure. Okay, so sequential structure is just you write lines of Python source code. Those will all get executed, starting with the first one, ending with the last one. Alternative structure, that is the if statement, including elif and else. Repetitive structure, that will be the for Python keyword. So let's see what repetitive structures are useful for. They are useful in cases where you want to do the same thing multiple times. So for instance, let's say that we want to print 10 times to the console, to the terminal, the text hello. So that would be print hello, print hello, and this thing 18 more times. One, two, three, four, five, six, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 times the print hello statement. The output is correct, so 20 times wrote the word hello to the console. But then this source code is repetitive, which means that if we'll ever fix an issue, a bug on line 5, we will need to pour that fix everywhere, which is tedious. Then it's very error prone because it should print 20 times. So you need to actually count the numbers, the number of times you have the print hello source code line. I also was forced to put a empty new line in here in order to separate 10 prints from the next 10 prints. This way it's easier for me to actually count them, because it's not easy to count 20 identical source code lines. What happens if you need to have 100 identical source code lines? So in order not to do that, what we can do is tell Python, please re-execute line 5 20 times. Let's see how we can do that. For that, we will need a list of 20 integers. So that would be my list equals, and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is tedious also. Eleven, 12, 13. And then we can say for each of these items, print hello once. So let's see how we do that. We use the repetitive structure for, so that's the syntax for it being for. Then the iterator variable, let's say I know I, in my list, colon, and then it automatically enters a new block of code by using a for space indentation, like this. Let's run it. And the output is the same. It writes 20 times hello to the console. So this version of the program is very much improved to what was before. But there's an even simpler version, because creating these huge lists is also error prone. So for that we have the function range. So range has as first parameter the start index, which is 0 in our case, and then we want it to go to 20, which means the last parameter, the second parameter, should be 21, because range goes from 0, 1, 2, 3, 4, and then it does not get at 21, so stops right before 21, which means 20. Okay, the same output, 4, 8, 12, 16, Let's actually see with the debugger what's the value of my range, range. We can't because it's a range. It's not actually a list. So I searched on Google for Python and then range. It found the web page from W3 Schools. Again, W3 Schools is a very good website. And in here says what I knew, that it starts at start, stops right before stop, not included. But then what was confusing was the fact that going from 0 inclusive to 21 not inclusive is 21 items. So the items are from 0 to 20 inclusive, but that's 21 items. So there's from 1 to 10, from 11 to 20, that's 20 items, plus 0, which is the 21st item. So if you want to print hello 20 times, we must stop at 20. So should be from 0 to 19. Okay. Let's run it. It works correctly. Now we don't even need a local variable to contain the range. Let's see exactly what my list is. We did this before. It's not actually list. It's a range. So it says class range 0, 20, where this function is actually the constructor of the class range. Okay, and there's constructors for start, stop, step, constructor just for stop, and their constructor with parameters start and stop. So even this can be further simplified by not specifying the start because 0 is implicit. And this can also be simplified by not having the local variable myList and moving the constructor myRange in here. So you get for I, which is the loop variable. This variable exists inside of the block of the for and takes values from 0 to 19 and then prints will run for the loop block. Let's have two instructions inside of the loop block. Print loop variable is or value. Let's run it. So there's a hello, then the value of the loop variable is hello, value of loop variable is, and the loop variable goes from 0 to 19 as we wanted. Okay, so similar to the if structure, there's the first line which has the syntax. In this case it's not if but for, so for the name of a variable in and then something that's iterable, a list, a range, a tuple, a other containers, and then colon and then indented by default with 4 spaces the body of the loop. So in this case, the body of the loop are lines 6 and 7. The repetitive structure is lines 5, 6, and 7. Let's run this thing with a debugger to see how Python interprets lines in which order. Okay, so these were comments. Python skipped over them. This was an empty line, line 4. Python skipped over it, and now Python is at line 5. It says in here loop.py line 5. And then we can also see the background of the line 5. We go step over because there are items inside of the iterable, inside of this thing, inside of range 20. There's actually 20 items. The first item is picked up from the iterable and placed into the loop variable, which is I. The first element which is returned by range is going to be 0. 0 is stored into the local variable loop variable I, and then it will go to line 6. Line 7. At line 7 we can see that I has value 0. And then when we go step over to run the next line, so let's see what line is interpreted next by Python. This should be line 5, where I receives the value 1. Step over, I should be 1, and it will go to line 6. Okay, we can see in here that I is 1, and we can also inspect it by hovering on top of the I variable. And then it goes to line 7, line 5, I will be 2, line 6, line 7, line 5, I will be 3, line 6, line 7, line 5, I will be 4, line 7, line 5, I will be 5, line 6, line 7, line 5, etc. We can also see the value of the I variable in here, in this tool window. So the tool window debug alt 5 and the expression part. Okay, so step over a million times. 19 is the last value, so I receives the value 19, is assigned the value 19. Line 6, line 7 returns to line 5. There's no more items inside the range. 19 is the last. There's nothing to assign to loop variable I, and 4 will finish. Next will be line 8 interpreted, which is the last one, so the process will stop. Okay, and now the process will stop. Okay, let's look at some other examples. So we have a list with characters, so strings, but of only one character. Other programming languages have the type character, but Python has the type string, and you're just putting one character inside each and every string. Okay, 4, and then we need a loop variable. Could be named any way, so you can give any name to the loop variable. Don't forget the semicolon, the colon. So after the line with the keyword 4, you should have a colon, which then needs a block after it. So the indentation will automatically be put by the integrated development environment. So for spaces, that's the default. for indenting. You can indent with 2 spaces, with 6 spaces, with tabs, with many other things, with 20 spaces if you want, but the standard is 4 spaces. Okay, what do we do in the body of the 4? We just print the letter. Okay, let's now run it. It says A, B, and C. Okay, so it does not matter how you change the list or what values you put inside of the list. The letter loop variable will be assigned each and every item in the list. So you'll be assigned this item, this item, this item at each iteration of the 4 repetitive structure. So now it should say A new line, B new line, C new line, D new line. So between A and B, there's an invisible new line, which makes the console advance from here to here. Okay. What else can we do? We can complicate the print line. We can say, for instance, letter like this. Or we might use string concatenation instead of 2 parameters to the print function. Like this. Don't forget to put a space in here. When you do concatenation, if you don't do concatenation, then you must delete the space. And the output should be the same. Okay, let's prove that we can name the loop variable anything. Loop var. And we run it, indeed we get the exact same output in the console. As you saw, when I renamed the loop variable, because the loop variable is used on line 4, we also needed to rename the loop variable on line 4. So instead of us editing 2 lines in different places just to rename a variable, we can use a feature in the integrated development environment PyCharm, which is called rename refactor. So let's do that. Right click, refactor, rename, and now we'll rename this variable, loop variable, to whatever else. 1 character. And it will rename in both places, both on line 3 and 4. And if you have this loop variable in other 20 places inside of the body of the 4, then it will replace everywhere. Because the integrated development environment understands the Python source code that you wrote, it will do the right thing. For instance, if you have a comment in here, it should not touch it. So refactor, rename. What do we rename this thing? 1 item. Press enter. So it renamed all of the variables, did not change our comments. Okay, so at each iteration inside of the body of the 4, we will have access to the items of the list. So first we will have the local loop variable 1 item have the value, the string A, then the string B, string C, string D. What if you want to also have access to, inside of the body of the loop, we want to have access both to the first item, which is A, and its value, but also to its index. So we should have access both to 0 and the string A. In the next repetition to 1 and the string B. There's multiple ways to do it, but one of the ways to do it is to compute the index by using the method of the list, which is called index, which has as first parameter the value. So we give it the current value of the loop variable. It will return at first iteration, we will have the string A inside one item, and if we say mylist.index of the letter A, it will say 0, so this will be 0. And then we can print, let's also increment this by 1, not to be 0 based, but to be 1 based. And this will allow us to print more details about one item in the list. So we go letter index, and then this is its value. Okay, so it says letter 1 colon A, letter B colon B, letter 2 colon B, letter space 3 colon space C. And this is the last one. Let's also look with the debugger at what's happening there. So there's a list with values A, B, C, D. Now we have one item with value A. We can see it once here, then here, and also if we hover on top of the one item. Now it should go to line 5, and letter index will be a variable declared with integer value 1, which we can see it in here and here. If we press step over, it will print to the console, which is this one. It will print to the console letter space 1 colon space A, this one. Advances to the line where the for keyword is. So for one item in my list, which is line 3. And this line will assign to the loop variable one item the next item, which is going to be B. And it will, execution will continue with line 4. So one item is B, we're at line 4. When I press step over, it will advance to line 5, and letter index will be 1 plus 1, which is 2. Then it will print and go to line 3. One item will be C, letter index will be 2 plus 1, which is 3. We'll print, go to line 3. One item will be D, letter index will be 3 plus 1, which is 4. We'll print, we'll go to line 3, and the items, there's no more items inside my list after D. So we cannot assign anything to one item. So the 4 has finished. We'll go to line 6, which will end the program. End the process. Okay, another example, we're going to look at a list of names, and there's multiple names starting with the letter L. So we have John, Luis, Mary, and Lyndon. And let's have also Linda. Okay, so we have multiple first names. The loop variable will be named name. In my list, for name in my list, we're interested in which of the names start with L, with uppercase L. Okay, so that's if name, there's the method starts with, and should start with a string uppercase L. And then we have the end of the if line, which ends with a colon. When we press the Enter key on the keyboard, it will jump inside of the then block of the if. So we have double indentation. This if line, so lines 4 and 5, have 4 spaces indentation because we're inside the block of the 4. And then on line 5, we're inside of the block of the 4, but we're also inside the block, of the then of the if. So that's why we have double indentation, which is 8 spaces in this case. We print the name. When I press Enter, the integrated development environment will not know if I want to be inside the block of the then, if you want to be inside the block of the 4. So if you want to continue writing lines inside of the block, inside of the then block, I can start writing. If I want to be inside the block of the 4, I need to delete 4 spaces. If I want to be outside of the 4 repetitive structure, I need to delete 4 more spaces. Like this. Okay. So there's 3 names starting with L, Louis, Lyndon, and Linda. We have the breakpoint on line 3, and we'll look with a debugger how it looks like. Let's go to the console tool window, the console tab, and step over. So step over means go to the next line that Python interprets. So Python is an interpreter, interprets lines of Python source code by certain rules. So in a certain way, some lines are read by the Python interpreter, and by going with the debugger, we can see which lines are skipped by the Python interpreter, which lines are interpreted, so executed by the Python interpreter, etc. So let's start from scratch, because this way we will see that line 1 is interpreted by the interpreter. So we're on line 1 that gets interpreted or executed. There's nothing on line 2, so Python will skip line 2, go through straight to line 3. We're on line 3 where it says that my list is a list with 5 items. The first one will be assigned to variable name, which is the loop variable. Then we enter the body of the 4, which is lines 4 and 5. Inside of the body of the 4, there's just one thing, which is an alternative structure if. Let's run line 4, which says, does name start with L? So name is John, does not start with L. The next line to be executed by the Python interpreter is not line 5, because this is the then block, and the then block gets executed only if the boolean condition inside the if line is true. And in this case, it's false. So John does not start with uppercase L. Line 4 is skipped, and we go to line 3. On line 3, name will be assigned the next item in the list, which is Louis. You can see it in here and in here. And then, does Louis start with uppercase L? Yes. So we're inside the body of the then body, the then block. And in here, there's just one line in the then block, line 5, which says print name, which will print Louis to the console. We can see Louis printed here. And now we're back at line 3. The next item to be assigned to the local variable, loop variable name is Mary. Mary does not start with an uppercase L, so line 5 will not be executed, line 3 will be executed. The next item in the list will be assigned to loop variable, so that will be Lyndon with uppercase L, which starts with uppercase L. So the then block will be executed, which is line 5. we will see Lyndon printed to the console. Then it goes to line 3. Name will be assigned the last item in the list, my list, which is named Linda with an uppercase L. Linda starts with uppercase L. Linda will be printed, and then execution will go to line 3. Inside of the for, the Python interpreter looks inside of the list, my list, sees that we're currently at item Linda, and tries to advance one item. Tries to find the item that's inside my list after Linda. There's no such thing, nothing to be assigned to the loop variable name. So execution jumps to line 6, which is empty, which then the execution will actually jump to line 7. Okay, then execution will go to line 8, that's empty, and the final one, so the process will finish. Exit status 0. Okay, so in order to make it more evident that some items exist in my list which do not start with an uppercase L, we can, for instance, have an else, and then the else block, where we can say something like print the name does not start with uppercase L. Let's run it. And says the name John does not start with uppercase L. Louis, the name Mary does not start with uppercase L. Lyndon, Linda, and then Don. You can also see this thing in the debugger. So name will be John, condition will be false, the else block will be executed. Next name is Luis, condition is true, Luis will be printed. Next name is Mary, condition is false, the name does not start with L will be printed. Name will become the next item, which is Lyndon. Starts with L, so the condition in the if is true. It will go to line 5. Then we'll go to line 3. The next item in the list is Linda, will be assigned to the loop variable name. Starts with L, condition is true, goes to line 5, goes to line 3. There's no more items to extract from the list and place into the loop variable. Execution goes to line 8, 9. Execution finishes. Okay, so we saw how we can use for loops in order to execute the same thing multiple times. We also saw how to iterate through all items and decide based on what the item looks like with the alternative structure. But we can also use a for loop to do mathematical operations, such as sum of all of the items inside of a list. Let's see such an example. So numbers is a list with does not matter which numbers. Then we have this sum variable, and then we have a for loop. And at the end, we print the value of my number. My value. Okay, let's see how it looks like. So it just printed at 15, and then the process has finished. Let's look with the debugger at what's happening here. So we're on line 1. numbers local variable will be declared, list with integers from 1 to 5. My value local variable of type integer will be declared with initialized with value 0. Execution is at line 4, which is a for instruction. Says number in numbers, so the loop variable is named number. The list is named numbers with an s at the end. So the first item in the list, which is 1, will be assigned to number. We can see that here. And then my value has the value 0, number has the value 1, 0 plus 1 will be 1, the right hand side will be evaluated to 1, and 1 will be stored inside the local variable my value. Okay, so my value used to have a value 0 on line 2, and now it has a value 1. So the value of my value has incremented with the value of the first item in the list. Okay, we're at line 4. Number will be the next item in the numbers list, which is 2. The right hand side is my value, which has value 1, plus number, which has value 2. So that's 1 plus 2 is 3. My value will be 3. So inside of my value, we have 0, plus 1, plus 2. Now number is 3. My value is 3. Number is 3. 3 plus 3 will be 6. My value will be 6. My value is 6. We can see it here and here and here. We're at line 4. Number will be assigned the value 4. My value is 6. Number is 4. 6 plus 4 will be 10. My value will be assigned the value 10. And now we're at the last iteration. So number will be assigned the last item in the list, which is 5. My value is 10. Number is 5. 10 plus 5 is 15. My value will be assigned the value 15. So that's the last value of my variable, of the variable my value. There's no more items inside numbers. We have used the value 5, and now number has nothing else to be assigned. Execution will go to line 7. Line 7 will print the value of stored inside the variable my value, which is 15. And we can see it in here. So what it did was do 0 plus 1 plus 2 plus 3 plus 4 plus 5, which is the same thing with doing the sum of all of the items inside the list. So 1 plus 2 plus 3 plus 4 is 10, plus 5 is 15. Again, pay attention to indentation. What happens, for instance, if we put 4 spaces in here on line 7? Let's execute. And it has printed not just 15, but 4 other numbers, which are the intermediate values of the sum. Let's go with the debugger and see what happens there. So step over, and now it enters the loop body, which the loop body used to have just one line, which was line 5, and now it has 3 lines, the loop body, lines 5, 6, and 7. So 5 goes to line 7 because that's inside of the block of the loop, then goes to line 4. Line 5, 7, line 4, line 5, 7, line 4, line 5, 7, line 4, line 5, 7, line 4 the last time, and then the execution finishes. It already printed all of these numbers. Let's run with the debugger and look at the console. 1 was printed, 2 was printed, 3 was printed, 4 was printed. Not 4, but the sum until the item 4. So 1 is the intermediate sum of 0, 1, and 2. 3 is the intermediate sum of 0, 1, 2. 0 and 1 is 1. 0 and 1 and 2 is 3. 0 and 1 and 2 and 3 is 6. 0 and 1 and 2 and 3 and 4 is 10. 0 and 1 and 2 and 3 and 4 and 5 is 15. And it also seems that it does not matter what indentation is on line 5, on line 6, even if there's 0 indentation, because there's 4 spaces on line 5 as indentation, and the same 4 spaces on line 7 as indentation, then lines 5 and 7 will be part of the same block, which in this case is the body of the 4. What happens if we delete a space? So this fails, says that indentation level of just 3 spaces is unknown. So this is the exception indentation error. Unindent does not match any outer indentation level, whereas this one matches the indentation level of line 5 if I put 4 spaces on line 7. Okay, so we have used a range, we have used lists. What about strings? Can we iterate inside strings by receiving each of the letters inside of the string inside the loop variable each time the loop repeats? So that would be word equals test. And then for this would be letter in word. We'll print the letter. Let's actually use the refactoring. So refactor, rename, this would be letter. Press enter, run, and it works correctly. So strings behave similarly to lists of characters. And at least we can iterate all of the characters inside of a word. Similar to lists, we can iterate through items, but we can also index. We can go word and then square parentheses of 0 to get the character at the first position in the string, which is T, lowercase. Okay, an even more simplified version would be to not have the local variable word. And it works identical, shows the same output in the console. Let's rename again this loop variable. So make this item. Run, it works correctly. So we can iterate inside of a string. We can also iterate directly inside of a list of integers. We can iterate inside of a list of anything. So it writes 1, 2, and then test, because these are the 3 items inside of the list. We can use, instead of a list, we can use a tuple, and that works too. And there are other types which are iterable. The list can also contain other lists. So we saw as list items, integer, string, but we can also have list in here. So 0 and 1, and then 2 and 3. First item is a list, second item is a list, third item is a string. Could be also a list. 4 and 5. We can also do more advanced things. So this list contains lists of at least 2 items, which means we can have at each iteration one of these sublists, and then these sublists can be destructured into multiple variables. For instance, we can have v1 and v2 for variable 1 and variable 2. Let's print them on separate lines. v2. Okay, so it prints 0, 1, 2, 3, 4, 5. How come? At first iteration, the item array, item list 0 and 1 is returned. That list is then destructured into these 2 variables. So the first item in the list is placed into v1. The second item, which is 1, will be placed into v2. And then we print inside of the body of the loop, inside the block of the for, which is executed once, we'll have v1 0, v2 1, which will generate this printing. Then execution will go back to line 2. This item from the list will be chosen, destructured to 2 and 3. 2 will be placed inside the variable v1, 3 inside the variable v2. It will print 2 and 3, these things. Execution will go back to line 2. This item inside of the list will be taken, destructured to 4 and 5. v1 will be 4, v2 will be 5. And then 4 and 5 will be printed. Execution will go to line 2. There's no more items to get from the list, from the list. And then execution goes to line 5 and finishes. Let's actually see this thing. This thing, okay. So we're at line 1. Now it's picking the first item in the list, which is the list 0 and 1. This step over button. Destructure to 0 and 1. The first item, which is 0, put in the first variable v1. The second item, which is 1, put in the second variable, which is v2. And then it will print 0 and 1. Execution will go is already at line 3. The next item in the list will be chosen, which is 2 and 3. Destructure to 2 and 3. v1 will be 2, and v2 will be 3. 2 will be printed, 3 will be printed. 4 and 5, the item in the list, which is the list 4 and 5, will be chosen. Destructure to v1 and v2, and then printed, which is 4 and then 5. No more items, the process will finish. We can also iterate inside of dictionaries. So we have my dict equals a dictionary, which is pairs separated by colon, and then the pairs are separated with commas. So the first key is key 1. the first value is A. The second key is key 2. The second value is B. Third key, key 3. Third value, C. Okay. This will be one loop variable. This will be my dict, and it will print item, and also the type of item. Okay, so we have a repetitive structure. This line, repetitive structure plus the declaration of my dict, is a sequential structure. Inside the block of the 4, there's just one instruction, line 3, print the type of the item and then the item. How does that thing work? Dict is split by comma. The first pair is returned first, then the second pair, then the third pair. The pair will be stored inside item as a, I'm not sure what, hopefully a tuple. No, it only returns the keys. That's interesting. And if you want to also print the values, we'll need to go print key. Let's do that. So the key is inside item. And the value is my dict of item. Shift F10. So key 1 has value A, key 2 has value B, key 3 has value C. If we want to actually return at each iteration not just the key but the entire pair, then we have the member method of the dictionary, which is called items. So we're using the method items of the dictionary, which returns a, let's look at the signature. A set-like object providing a view on these items. What is that? So it returns at each iteration one tuple of the items. So the first item as a tuple, the second item as a tuple, the third item as a tuple. And we can see in here, because it says that the type of item is tuple. And then if we print item, it shows the two elements surrounded by round parentheses, which again is for tuples. So there's two items, key 1 and A, inside of a tuple. And if we want to print inside of each iteration the two elements inside the tuple, key and then has value, like this. This is one way of doing it. Item, which is a tuple, we index at the first position, which is index 0, and then we index at the second position, which is index 1. We can also go once with the debugger. So item will be tuple, two items, key 1 and A, both strings. It will print once. Class tuple key 1 and A. It will print twice. Key 1 has value A. Back to line 2. line 3, 4, back to line 2. And this is the last time we enter the block of the loop. So item will have the last value possible in the myDict, which is key 3 and C. Print once, twice. Back at line 2. No more items inside the dictionary that were not visited. And goes to line 5 and the process finishes. Okay, if we only want the values, then we have a method for that, which will return first time A, then B, and then C. As strings, of course, because that's what we have in value 1, value 2, and value 3. Okay, and then when we went with items, each time the loop iterates, the loop variable receives a tuple. So the first tuple will be key A, the string key A and the string A, which we can destructure as k and value, and then we can print both of these. Okay, so at the first iteration, myDict of items returns the tuple with the string key1 and the string A, gets destructured for k and v. So k has the first item in the tuple, which is key1, the string. V receives the string A, and then we print both the type and the value. So class str key1, class str A. Iteration goes back to line 2. The next time, the method items returns the strings key2 and B as a tuple. Get destructured. K is key2 as string, V is the string B, and that gets printed here. Okay, so there are two repetitive structures. The first one was the for. Now we have the second repetitive structure, which is the while. So let's say that we have a coin machine. We have coins, 5 coins. And then while I still have coins in my pocket, I'm going to do something. In this case, we will just print. I will say the number of coins. There are coins. Coins. Okay, so this is the entire Python program. On line 1, we declare local variable type integer numeric with a value 5. And then this is almost identical to having an alternative structure. If we go if coins greater than 0, then this would be the then block. It will get executed because 5 is greater than 0. So this evaluates to the boolean true. Let's see it running. So this would be an alternative structure, but in here we're talking about the repetitive structure while, which does not use the if keyword, uses the while keyword, but is somewhat similar to an if. So we go while, then a boolean condition, colon, and then indented with 4 spaces, there's the block of the while. Let's see what happens. Let's use breakpoints and the debugger. So we're at line 1, it will go to line 3. Condition will be true because 5 is greater than 0, goes to line 4. It will print there are 5 coins, goes to line 3. 5 greater than 0, so the Boolean condition is evaluated again because either the right-hand side or the left-hand side of this comparison might change as we run the program. Goes to line 4, prints there are 5 coins, goes to line 3, true, prints there are 5 coins, goes to line 3, 5 greater than 0, true, goes to the body of the while, just one instruction, just one Python source code line inside of the body of the while, so in the block of the while, which is to print there are 5 coins. There are 5 coins, there are 5 coins. This program will never ever stop. So that's problem number 1, that the program will never stop, and all programs should stop one way or another. And the second problem is that it will run so fast, so it will never stop, and this while will repeat so fast that it will use most of the resources of the computer. So it will be very hard for you even to stop this program, because much of the central processing units or the processor of the computer will be used by just lines 3 and 4 in this example program. So let's actually run it, not debug, but run. It will type millions of times there are 5 coins. And we can hear the fan of the computer starting to rotate. So you need to remember that this is something that you must avoid, which is called infinite loops or infinite cycles. We will need some way of exiting this while. How do we exit the while? Only when the condition in the while becomes false. So for instance, we might, inside the body of the loop, do something like if the hour is past noon, then coins becomes 0, just so that coins is 0 greater than 0, 0 is not greater than 0 will be false, and the while will finish. But that's also, it will be a very heavy cycle on your computer for the next 20 hours or 12 hours. So you will need somehow to change one of the variables that are used inside of the condition of the while, such that the while repeats a really low number of times. Rarely you need to run the body of the while millions of times. Usually you run it, I know, less than 100 times. Okay, so one way of doing it is at each iteration we print the number of coins remaining and we decrease the number of coins remaining. So we go coins equals to coins minus 1. Let's see how that works in the debugger. So 5 greater than 0, that's true. We'll print there are 5 coins. And then coins equals coins minus 1. So coins starts at a value with a value 5 stored inside the variable coins. 5 minus 1 will be 4. Coins will be assigned a value 4. Goes to line 3, 4 greater than 0, which is true. Prints there are 4 coins. Now 4 is the value of coins. Minus 1 will be 3. The value 3 will be assigned to coins. 3 greater than 0 is true. It will print there are 3 coins. Coins has the value 3, minus 1 will be 2. The value 2 will be assigned to coins. Coins is 2. greater than 0, true. There are 2 coins. Coins is 2, minus 1 will be 1. Coins is 1, greater than 0, true. Print there are 1 coins. Coins is 1, minus 1 will be 0. 0 will be assigned to coins. Back to line 3, coins is now 0. 0 is not greater than 0. The condition will be false. Execution will go to outside of the repetitive structure. The repetitive structure will be over. We'll go to line 6, which is the final line, and the execution will finish. And you can remember that we have operators with a mathematical sign and then equals. So for instance, minus equals to 1, which is a shorthand notation for exactly what was before. So coins equals to coins minus 1 is absolutely identical to coins minus equal to 1. That's the definition of minus equal. So the definition of minus equal is that coins minus equal to 1 is identical to coins equals to coins minus 1. We can run it, we'll see the exact same output. So there are 4 coins going down to there are 1 coins. Okay, so also similar to the if, we can have an else block. The else block is executed just once when the condition is the first time false. So the first time that the condition is false, I have coins equals to 0. That means I have 0 money. I have no money. Okay, so 5 times it writes there are coins. The 5th time it says I have no money. We can also use the debugger. Step over is F8, so let's go really fast. F8, 1 coin, 0 coins, and now says while 0 greater than 0, 0 is not greater than 0, so that condition is false. The first time that the condition is false, the block of the loop will not be executed. Instead, the else block will be executed. So goes to line 7 and then finishes. Okay, so this counting down from 5 to 1 seems really similar to what we can with the for loop. In there we can do ranges with negative step, for instance, or we can have a list that goes from 5 to 1. And indeed we can obtain a similar output using both a for repetitive structure or a while repetitive structure, at least when these are the requirements of the program that we need to write to have this output. But then there are more complex scenarios where you don't iterate through the items in a list, when you don't go ascending or descending in a progression. And for instance, such a possibility is when you keep asking the user for input. Let's see such an example. So we have a local variable which holds what the user enters from the console. So we say while the answer is yes, we can ask the user for the new answer. should we continue? And the possibilities are enter Y or N. Like this. Okay. The user wanted us to continue. Nope. We can't say such a thing. Enter Y or no, and then if the answer is Y, we ask the user again. If the answer is not Y, could be anything, could be empty, but hopefully the user enters N. We will go to the else branch, so the body of the else, the block of the else, which will say print we should not continue anymore. Done. Okay, let's see how this works. So via standard input, via the terminal, we ask the user, should we continue, enter yes or no. The user enters yes. Then the user is asked again, should we continue, yes or no. The user continues to provide the character Y. And now this time it will provide the character N. Else, the block else is executed, and then execution stops. We can also see it with the debugger. So we're at on line 1, where answer variable will be declared and will be a string with a value string Y. Step over. Now we're at line 3. Is answer equal to the string Y? Yes, it is. We ask the user to give us the character Y or N. The user enters the character Y. The execution goes to line 3. The answer is yes. So the condition is true, so answer is yes. Yeah, whatever, Y. Y is equal to Y. Yes, it is. So the condition is true. The while block is executed. The user will be asked again to enter Y or N. The user enters again Y. We're back at line 3. Answer is Y. Y equals to Y, so the condition is true. The body of the while will be executed. The user will be asked again, should he continue, yes or no. This time we'll print N and press enter key. And now we're at line 3. So answer is the string N, and that's not equal to the string Y. The condition is false the first time. So the else block will be executed just one time. It will jump there. And then execution will go to line 7 and the process will finish. So in the console it wrote, we should not continue anymore, done. Next up is the Python keyword pass. So what that is used for, sometimes we know the line of the while, so we know which condition should be evaluated by the while, but we do not yet know what to put inside of the block of the while. So you might say, let's ignore the block of the while for a while. and do something else. Print the final line of the program, which sometimes is done. If we try to execute now, Python will give an error, will say exception indentation error, expected an indented block after while. So if Python finds a line that says while condition and then colon, it also expects to be an indented body of the while, even if that doesn't do much. So you can put anything there. For instance, we can put a temporary print statement, which doesn't print anything. This is okay. Not okay because it's an infinite loop. So don't do that. How do we stop execution? This button. Okay, so don't do that, what I did. In order to have an empty block, we have the keyword pass. Let's see how executing works. It's as bad as putting a print, so it's an infinite loop. So don't do that either. The next Python keyword related to the repetitive structure is break. What break does is if we're inside the body of a loop, so the body of a for or the body of a while, we might decide enough is enough. Let's get out of the repetitive structure altogether. So for that, we would use the break keyword. So let's see an example. So we ask the user to enter a name, a first name. Let's make this first name. And then we want to iterate through all of the characters in the string. So for item in first name, we want to print the item. So the item is actually a character or a letter. Let's run the program. So it says, please provide the first name John. And at each iteration, we'll do print. So we'll print one of the characters, the first one being J. And then when print finishes, we'll print a new line, which is this invisible character. At the next iteration, we'll print the O and the new line. At the next iteration, H and new line. At the last iteration, N and new line. Okay, but what happens if we want the program to not write the character O and stop writing all of the characters after O? So it should stop and not continue writing the characters the first time it encounters an O. So that would be an alternative structure. If you encounter the letter O, stop doing the repetitive structure, exit out of the repetitive structure. So if the item is the lowercase letter O, which is the second in the word John, then the condition would be to exit the repetitive structure, which in this case is the for loop. Let's see it running. Asks for a name, John. Press enter, and then the iteration starts. Item is uppercase J, different than O. So the condition is false in the if. The then block will not be executed. This is the if statement. This is the block of the body of the loop of the for. The next instruction to be executed is line 6, which prints uppercase J. Then execution goes back to line 3. Item will be the next character in the string John, which is lowercase o. If item, which is lowercase o, equals string o, which is true, then the body of the then, so the then block will be executed, which says break, take me out of the repetitive structure, this one, which actually goes to line 7, which is the last line, and then the program finishes execution. Let's look with the debugger. So goes first name, input, please provide the first name. Step over. Let's provide the first name, Sean. And then I need to press the enter key. And now we're at line 3. So first name is John. Line 3 says item in first name. So item will be the character, the string uppercase J. We can see it in here. So if we hover over item, we can see it in here, and we can also see it in here. Item is uppercase J. Okay. We're at line 4, which is the if statement's condition. Uppercase J is not equal to lowercase o, so the then block is not executed. The if has finished, and Python executes the next line after the if block, after the if statement, which is this print, which has nothing to do with if. So it goes to line 6. Line 6 will print uppercase J, this one, and a new line. Then execution goes to line 3. Item will now be the next letter after uppercase J, which is lowercase o. Item is lowercase o and is equal to lowercase o, so the condition is true. It enters, execution enters the then block, which has just one line, which is line 5, which says break, which means exit out of the repetitive structure. This thing, so lines from 3 to 6 are the repetitive structure. So execution goes to line 7, which stops the execution because that's the last line in our Python source code. And that's it. We can eventually look with a word that has the letter lowercase o not on the second position, but on the, 5th position. So let's go with the name Ricardo. We'll execute with the debugger. We'll go to the line input. It asks for a name. We're going to go with Ricardo. And then we press the enter key. We're at line 3. We'll press F8 many times. So F8, line 4, R, uppercase R different than O. Line 6, line 4, line 3. The next item is I, so item will be lowercase I. Lowercase I different than lowercase o. Line 6, line 3. Item will be lowercase c, different than lowercase o. The if will not be executed. If the if statement would have an else, then yes, that would have been executed, but the if only has a then block. So we print the next character, which is lowercase c. Line 3, item will have value lowercase a. Then lowercase r, lowercase d, and now we're at lowercase o, which is equal to lowercase o, break, and then execution will stop. So this was the break Python keyword, which can be used inside repetitive structures, inside of for or while. there's another Python keyword which is called continue. Let's see how it works. We're going to provide Ricardo, and it wrote RICARD without the final O. Why? Because when the loop variable, the iterator item, has the value O, then execution enters the then block, which runs the continue keyword, which skips back to line 3. So from line 5 goes to line 3. That's what continue does. It finishes the current iteration of the loop and goes back to the condition of the loop, to the line where you defined the for or the while instruction. So let's look with the debugger at this thing. Console, step over, says we should provide a name. Press enter. We're on line 3. Okay, so item will be uppercase R, different from 0. It will not enter the then block. Prints the R. Next item is I, lowercase, not equals to lowercase o, does not enter the then block, does not execute the continue, etc. until at letter D. And now the next item will be O, lowercase, which is equal to lowercase o, so the condition of the if is true. The then block will be executed. The then block has just one instruction on line 5. Continue will be executed, which will make that the rest of the block of the for will be skipped, which means just line 6 will not be executed. And execution will continue back at line 3, so before the block of the for. After item O, there's nothing else, no extra character after the final O in Ricardo, and the execution finishes. Next up is the range in Python. So in order to create a for instruction, you would go for item in my list. And then, for instance, we want to print all of the items. We want to print the integer numbers 1, 2, 3, and 4. For that, we will need a list which contains those numbers 1, 2, 3, and 4, which might be written by hand. And 4. And now the output of the product is the program is what we wanted, which is on different individual lines 1, 2, 3, and 4. We have a better way of creating these lists, or a better way of creating the iterable object for the for by using range. So we can go range, and to go from 1 to 4, we would go, for instance, to 4. Let's print them. So it's 0, 1, 2, 3, and 4. And in print, we will print +1. So this is what we should have printed, 1, 2, 3, and 4. Or range. So let's see what range is. It's a class constructor. It also has another list of parameters, so might be just one parameter, which is the stop parameter, or might have a start and stop parameter. In our case, to go from 1 to 4 inclusive, that would mean that the range should start from 1 and not arrive at 5. And then we do not need to increase the values by 1. So it prints the same thing, 1, 2, 3, and 4. Okay, so we can start at any value and before any value. For instance, if you want all of the numbers from 20 to 30. So this is the interval that starts with 20 but ends before 30. So this is inclusive, this is exclusive. And we want to show all of the integers from 20 to 30. Then what we can do is increase this 30 by 1. We can either go like this or like this. And so we saw a range with one parameter, which is the end parameter, a range with two parameters, the start and the end. And then there's the range with the third parameter, which is the step. So for instance, we want only the odd numbers, only the even numbers. So 10 is in the range, the next one, 21, is not, 22 is, 23 is not. Or if you want 20 to be, but 20 to be in the list, 23 to be in the list, but 21 and 22 not, then we can increase the step even more. Okay, let's say we need a list which is very large to type by hand. For instance, we want a list that goes from 1 to 100. That would be a ton of typing, but luckily we have range. So from 1 to 100, that's 1 inclusive and 100 exclusive. So we need to be 101 exclusive. Shift F10. Unfortunately, this is not a list, so my list is not a list. Instead, it's an object of type class range. So we will need to cast this to convert the object of type range into a list. For that, we can use list. So conversion to list. So this would be the constructor of list from anything that's iterable. And now my list is a list and has the correct value. So between square parentheses, 1, 2, 3, 4, etc. until 100, including 1, including 100. Next up is Python enumerators. So let's say that we have a list and we want to print all of the indexes in the list and all of the values at that index. So in our case, we have strings. The program should output 0, which is the first index, and then A. 1, which is the second index, and then the value at index 1, which is B. And then 2, and then C. How would we do that? We could do it using a for loop. We need a variable. local variable that will keep the index and will increment this variable each time we print inside of the for loop. So you wanted to print two things, the index and the item. So you wanted to print 0a, new line, 1b, new line, 2c, new line. Let's see how this works. So it went 0a, 0b, 0c, which is wrong. We wanted 0a, 1b. We should not forget to increment the index, which we'll do using the plus equals operator. Okay, and now we have what was requested. So 0a new line, 1b new line, 2c new line. We can simplify this program by not having an index local variable and instead using enumerate. Let's see what this is. It's a constructor for the enumerate class. And in here we'll print the type of the item and the item. Okay, so enumerate is a constructor, takes as parameter an iterable container, and for each of the items in the container, in the list, it creates a new tuple. It keeps track of a index, so it goes 0 and a as a tuple. Next time when you iterate, it will return the tuple 1 and b. Next time when you iterate, it will return the tuple 2 and c. The list has finished. No more tuples to be returned. The for will finish. Okay. And now in order to print exactly what was expected of us to print, we can go tuple item of 0 and tuple item of 1. Shift F10. So this is the output that was requested. Another way of doing it is to know that the first time we iterate, in the for, enumerate will return a tuple, so that can be unpacked using the Python syntax for unpacking tuples, which would be two variables, which we can name as we did before, index and item. Both are integers, but let's print their type to make sure. Shift F10. So it's integer 0, string A, integer 1, string B. So this was the output that was required. We can use enumerate, the constructor, with something else than the type list. We can use it with anything that's enumeratable, anything that is a container that has sequences. So for instance, we could use a tuple, a dictionary, a range. Let's go with a range from 10 to 100. And an extra round parenthesis is required. So this closing round parenthesis is opened here. We can see that the pair of parentheses is highlighted. Okay, so for all of the items, an index is being kept. So the first item will be index 0, the second item will be index 1, etc. until 100, which is index 90. We can also use enumerate in other circumstances than when having a repetitive structure. Let's go back to the list we had previously with the short one letter words. So let's see enumerate of my list. So this returns an object of type enumerate, but we want a list of tuples for each item. We want a tuple with index and the item in the list. So we need to convert this to list. Let's print it and see what's inside. So it's a list. That's the first container. And inside on each of the items, there's another container which is a tuple. We can also index inside of the list of tuples. So we can go print. Then let's say we want to print the 1, which is the index for the string B. How do we get there? So we want my list 2. This is the entire list. We're after this element. So for that, we'll need to go here. So that's inside the list, the second item. So this is the first item, then comma, and then the second item. The second item has index 1. And inside of here, this is a tuple. So inside of the tuple, we want what's at index 0. And here is this one printed. Next up is the zip. So the zip will take two lists or two iterable containers as parameters, and we'll look at index 0 in each of the containers. In our case, the containers are names and ages. We'll look at index 0, John, and 43 in the two lists, and we'll combine these two values in a tuple. So it will create the tuple John, 45, and that will be returned as a list. So a list with a tuple of John and 45. The second item of the list, the tuple Mary, 32. The third item of the list, the tuple Dan, 19. So let's see how that looks like. Names and ages equals zip. Okay, let's see what zip is. So zip looks like a constructor to me. Okay, or a builder, a factory or something. Names, ages, and let's print both the type and the values. So it's just a zip object. What we probably want is a list of these values. Okay, so we need to extract all of the values from the object zip that's returned by this zip function into a list. So it's a list with 3 items. The first item is a tuple, second item is a tuple, and the third item is also a tuple. Okay, so if the two lists that are parameter of zip have the exact same number of items, then it's clear what zip will return after you get all of the items inside of the zip by converting to a list. So 3 items in the first parameter of zip, 3 items in the second parameter of zip will return a list with 3 items. What does it do when it sees more items in one of the two lists? Let's see. Will it throw an exception? No. It returns the exact same thing because it returns the number of a list of the number of items of the shorter parameter. So ages has just 3 items, whereas names has more than 3. It does not matter how many. Could be 100 items. The returned list will have just 3 items, each of them being a tuple. Let's look at this zip constructor. So how do we do it? To see the documentation of all of the possible overloads of the zip. So there's two iterables like we did it, iter1 and iter2, but you can also have 3 iterables, 4 iterables, 6 iterables, etc. So let's see this with 4 parameters. So there's name, age, location, let's make these cities. Las Vegas. New York and Dallas. And a fourth item, which would be, let's make these first names and second names. Some invented second names. So first names, second names, ages and location. And now it returns the same a list with the same number of tuples, which is the count of items in the shortest list. We can make one of the lists even shorter. Let's make location shorter. So now we have two arrays of 4 items, one list of 3 items, one even shorter, just 2 items. And it returns just 2 tuples inside of a list. Of course, you can change the order of the parameters of zip. Do it like this. And the order in which the elements in the tuple are will be changed. So first comes first names, then ages, then location, then second name. So this allows us to do things like, for instance, we can use unpacking, destructuring to unpack all of these this tuple into 4 variables. So let's do that. We need 4 variables. So first name, age, location, one location, and then second name in names and ages, and then we can print with format. So let's go with the first one, which is first name, and then second name, is years old and lives in one location. Shift F10. Okay, so we have produced a complicated print. This line is complicated, has 4 variables in it, whereas we had no index local variables. We did not synchronize between the 4 input lists, and the source code is really short and readable using zip and tuple unpacking in Python. When working with iterables, with lists, with tuples, it's a good thing to use the min and max functions to actually compute the smallest and the largest of the values in that list. For instance, we can have the min, which is a function, computes the minimum of the given arguments. So let's say we have 10, 24, 9, and 17. And let's store this in a local variable and print it. Minimum print. Let's see what type it is. So it's a plain integer, and the value is the lowest in the given arguments parameters to the function min, which is 9. We can also compute the maximum. That would be max. So that should be 24. So again, an integer, and the value is 24. So we can pass any iterable. It could be a tuple, a list, I don't know, range or a number of parameters. Okay, let's declare a local variable, which is my list of these things. And it would work the same. So max of a list is the same thing as max with 4 arguments, the elements inside of the list. Or we could just not have a local variable and have a longer print line where it says that the list has minimum min of my list and maximum max of my list. So the list has minimum 9, maximum 24. So the list in this case is of integers, but could also be of strings. So we can have John and Mary. Let's have Dan also. So the minimum is Dan and the maximum is Mary. Because they're sorted in alphabetical order, all of the strings start with an uppercase letter of the English alphabet, and these are really sorted alphabetically. So D is before J and before M. Okay, and we can even not use a list, but just use a plain string. Danny. Let's have Danny. What's the minimum and maximum of the string Danny with an uppercase D? Minimum is uppercase D and maximum is lowercase y. Okay, so the minimum is not A, because A is lowercase. It's the first in alphabetical order, the first uppercase English letter in alphabetical order, not the first lowercase letter, because uppercase letters are before lowercase letters in what's called the ASCII table. So let's look at that thing. So on Google, I searched for ASCII table. And the first result in here is called ascitable.com. And this is the table that I usually use. So let's see why Danny in the word Danny, D is before A. Where is the letter D? It should be written with red. So uppercase D is this row with decimal 68, hexadecimal 44, octal 104, HTML 68, uppercase D. Whereas what we thought would be the lowest, the minimum, which is lowercase a, is decimal 97, hexadecimal 61, octal 141, and HTML 97. Okay, so the lowercase a as an integer is 97, whereas uppercase D as an integer is 68. 68 is less than 96. That's how we sort individual characters in a string using min and max. Let's now look at how min function works with a dictionary. So we have a dictionary, key 1 with a large integer, and key 2 with a small integer. What happens if we print min of my dictionary? It returns the key. So it looks just at keys and returns the lowest one, the minimum of the keys. So these keys are strings. They're sorting using the ASCII table. So k equals to k, lowercase e, lowercase e, y, but then the string 1 is lower than the string 2, which we can see in this table also. So we are looking at the red column where it says characters CHR. We're searching for a 1, so the string 1 has decimal value 49, whereas the string 2 has decimal value 50, which 49 is less than 50, so the string 1 comes before the string 2. What if we want to not look at the keys but look at the values? myDict has 3 ways of accessing. We can go myDict, you can go myDict.items, and myDict.values. So in this case, we do not care about the keys, we only care about the values. And the minimum is indeed 23. Next up, we are going to generate random numbers. Would be integer numbers or float numbers. For that, we have a series of functions. We will start with the first one, which is randint. Okay, this one returns a random number between a start and an end. So let's make the start number be 0 and the end be 10. Okay, and then we store this thing in a variable. Like that. If we try to run the code, it will say that it will throw an exception of type name error, where it says that the name randint does not exist. We are expecting that the function randint be predefined for us, but it's not. It's in another Python library, which we need to use in our Python source code. So from that Python library, which is called random, we might bring to our source code file either one symbol, one function, for instance, or all of the symbols exported by that Python module. And for that, we use the syntax from name of module. In this case, it's random, all lowercase. Import. And we can import all of the symbols. Not like this. Import. Partially initialized module random. Yeah, we should not have named our file with, we should never name our Python files with the name of existing Python modules. So please do not use random as the name of your file. Let's rename it. Where is the rename? Random functions. Okay. And now we can import from random the function randint, because random is obvious what it is. It's the Python module with the same name. It's not our own Python source code files. Okay. When we import randint, the integrated development environment PyCharm has autocompletion for all of the symbols that are exported from the random Python module. So there's randint, random, seed, choice, shuffle, beta variate choices, etc., etc., etc. The class random with uppercase R. So we're using randint in here. Shift F10. So R has a value between 0 and 10. We can see by hovering on the function randint, returns a random integer in the range a, b. And b is inclusive. That's interesting. Random is a module. Random variable generators. Okay, let's print the type of R and R. So it's an integer with a value 4. Each time we rerun the program, we will receive a different value. So 4 appeared 3 times, but that means it's random. It might return 100 times the number 7, and it would still be random. Okay, so in the module random, which is built in, provided by Python, when you install Python, you also have the random module available. There's all of these symbols exported, and we can import them one by one, such as randint and then seed, for instance. Or you can import all of the exported symbols to be available in our Python source code file random_funcs.py. Okay, so we saw randint, which has 2 arguments. A function has 2 arguments of type integer, returns a integer in the range 0 to 10 in our example, including 0, including 10. And then there's the function uniform, which has as parameters 2 floats, and it says that depending on the rounding, it could also be the b number. So we might go from 0 to 1. And let's run. So the return value is a float. And in our case, it's 0.40 and then sum. Again, random values each time we run the application. Okay, so as we saw, the number of decimals is pretty long. We might choose to see just 2 decimals. So for that, we can use the function round. Let's say 2 decimals. So 0.55, 0.08, etc. And round is a function, but it's shown by the integrated development environment PyCharm as part of built-ins.py. So these are Python symbols, so classes, class constructors, functions, etc. that are available immediately in your Python source code file without you having to import anything, without you having to specify any modules. Whereas the random functionality resides in a different place in the random module. Okay, instead of calling the function uniform with parameters 0 and 1, you can use the function random, so with an lowercase r. Random has 0 parameters. Okay, and it returns the same thing, which is a float number starting from 0.0 until 1.0. Let's see it in action. So this is when we apply the rounding to just 2 decimal places, or we can remove the rounding and see the random floats between 0 and 1 inclusive. Next up is a function that chooses from a list one item, one random item. So let's say you have the colors list with values red, green, and black. The function to use is called choice, and choice expects a non-empty sequence, which will be a list in this case. So choice looks at this list, goes at a random index. In this case, it went to index 1, which is the second item in the list, and has returned that item, which is the string green, as we can see in here. So string and green. If we run it again and again, it will return a random item from the list. The next function is called shuffle, which modifies the given list in place. So as parameter, it expects a sequence, but one that can be mutable. For instance, a tuple is not a sequence that's mutable. It's a sequence not mutable. Or a string is a sequence but not mutable. So a list is both sequence and mutable. So it changes this list, and then we can print the list. So it's still a list, but then instead of RGB, whatever, red, green, black, it's green, black, red, GBR. Okay. We can, for instance, use a list of other things, and it should work just the same. Even a list that we create using a range. So let's use a range from 10 to 100 and skip 5. Okay, we cannot shuffle my list because my list is of type object of type range. Let's look at this thing. So if you go just call the range constructor, it will return a object of type range, which is a sequence. You can extract items from there, but it's not mutable in place. Okay, it says the range object does not support item assignment. The solution is to convert the range, which is an object, to a list. Okay, and now my list is a proper list with class list and then enclosed in square parentheses. In the list, after it's created, the values will be 10, 15, 12, 20, etc. until 95. So 10, 15, 20, etc. until 95, because 100 is and is not included, whereas 10 is included. And after it takes 1, so it takes this 10, it will skip 4. Then it takes 15, skips 4, etc. Which is this skip equals to 5, the third parameter of the range function. Okay, so the items will be moved around in the list. The same number of items will be in the list. The same items will be in the list, but on different indexes, on different positions. So list comprehensions is next, which uses the for keyword and the if keyword in order to, for instance, generate lists. Let's see an example, and then we'll see what the list comprehension in Python is actually useful for. So let's say we want to convert a string into a list of characters. We have word equals to test. And in order to convert this thing to a list, the simplest way to do it is to actually convert it to a list. Okay, so this is what we're supposed to have as a result, but let's pretend that we do not know that we can convert a string to a list of characters. Instead, we will use a for loop in order to loop through all of the characters in the word and then append this to the final list, which is called my list. We will create an empty list, and then we go for item, which is actually a letter or a character in word. We'll append. And in here we have item. And the result is the one that was requested. Okay, so this is where we start using list comprehensions. So we delete the body of the for, so the block of the for and the colon, and then we say item again. So that is item for item in word. Cut everything and paste inside the square parentheses. Shift F10, and the outcome is the same, identical to the previous version of the program. So look at the syntax. Between square parentheses, item for item in word. Okay, so word is a string, item is a loop variable of type string, contains just one character, first T, then E, then S, then T. So all of those 4 strings of just one character each will be the items of the list mylist, which we can see printed on line 4. And this is the output at the console. So this loop variable is not necessarily called item. It could be called anything else. Could be a letter. Shift F10 works the same. Could be, a char, a character. And then also this word is not necessary to be a variable, could be just a string literal. It would work the same. If we want all of the even numbers from 0 to 20, that would be in this in part would be a range that generates those numbers. So 0 to 20 and evens only must be 21 because and is not included. This, let's make it not char but item again. So 0, 2, 4, etc. until 20. So this part for item in range generates various values for the loop variable, which is item, whereas this item is an expression. The simplest expression could be just the item, so just the variable, but could be also 0. And then it will generate the inside of the variable, loop variable item, there will be the same values, 0, 2, 4, etc. But then we will ignore the value of the loop variable and we always put the value 0 on each of the items of the list. And we know how many items exist in the list because we know how many items are returned by the for. Or we could use expressions that contain item. We could have item floor divided by 2. It could be the square root of item. What am I doing here? So the square root of 2 is not 1. Okay, so any expression in front of the for, we can have any expression that can contain the item or can not contain the item. It's not necessary that this expression contains item. Okay, back to item. We said that we could have both for keyword it's called the for statement here, And also we can have if. So such an example is for item in range. We know exactly what that returns. But then we will say that some of those items are not okay for us. For instance, we can say if item greater than 6. And now it has skipped 0, 2, 4, and 6. The condition is item is strictly greater than 6, not greater or equal. If you put greater or equal, then we'll have an extra item on the first position, 6. Okay, so that's the keyword for inside square parentheses, the keyword if in square parentheses. What about the keyword else in square parentheses? There would be else, and for all of the items that are not greater than or equal to 6, make the value be -1. Okay, that fails because it throws exception syntax error. Else is not allowed to exist here. So after for, if you have an if, that if cannot have an else statement. The solution in this case is to move the if-else part before the for keyword, like this. And now all of the items that are returned by range 0, 21, 22, 2, which are less than 6, which means 0, 2, and 4, are going to be replaced with -1. So it's either -1 or the value of the loop variable item, which is the value generated by range. So let's do an example. We have a list of measurements in feet. So this is a list, 10 feet, 12 feet, 42 feet. And then we want a similar list in meters. We will use list comprehension, so that's equals pair of square parentheses. Inside, we need to have a loop variable that goes over all of the values in list in feet. So that's item or item in LF. Let's print to see how it looks like. LM. Okay, so it's the exact same version values, 10, 12, and 42. But then we'll need to convert the individual values, so 10 to how many feet would be, how many meters would be. So 3.048 meters. And for that, the expression, this item, should not be just item, because then the items in list in meters will in fact be in feet. But we need to multiply 1 feet with 0.304. And these are the values. 1, 2, 3. The values in meters that correspond to the values 10, 12, 42 in feet. Next up, we have 3 exercises for list comprehension. We have a list of values And it says create another list named square values that consists of the numbers in the list values but squared using list comprehension. Okay, so let's see the first of all, we need to iterate over all of the values in the list values. So that's always item or item in values. Let's also print this thing. Shift F10. So now we have the exact same items in the original list available into the list that was generated using list comprehension, so square values. But we need to have each of these items, so 1, 2, 3, 4, be squared. So that would be item times item, or item to the power of 2. Each would do. Let's verify. And it's okay. Next. Exercise number 2. Create an even values list. So we have this list of values. We need to create an even values list, which consists of the numbers in the values list that are even. Okay. So again, we're going to put a loop variable for item in values. We're going to print it. And now we have too many values. We need to keep just the numbers that are even. How do we do that? We do it with a if. So let's put the if in front of the for. If item modulo 2 is even, so that's equals to 0. Let's put another pair of parentheses. No, it's not that. Else expected. So if we put if in front of the for, it must have an else. Otherwise, we must put the if after the for. Okay, let's see how it looks like. So 2, 4, and 6. 2, 4, and 6 are even. 9.5 is totally not even. So this would be the result. The program that was requested. For the following list of temperatures in degrees Fahrenheit, express these same values in a new list of temperature values in degrees Celsius the conversion between type of units is as follows. Degrees Celsius, let's see if we can copy this thing. So degrees Celsius equals degrees Fahrenheit minus 32 times 5 divided by 9. Okay. The list of temperatures is as follows. Temperature Fahrenheit 32, 212,275. Store this new list in a variable called degrees Celsius. Let's first print it. We'll use list comprehensions to compute the value of the list degrees Celsius. We'll start with the classic df. Let's see how it looks like, these exact same values. And now this expression part will need to be changed. So we're going through all of the items, that's good. We don't need to eliminate some of the values, so we do not need an if. We do not need to replace the value of item based on certain condition, so we do not need if. The only place where we can actually modify something is in the expression, so what's before the for. So in here we have an item which is one individual temperature in Fahrenheit. So the first value is 32. So we take this 32, we go minus 32 as it's explained in here. And then we multiply that thing by 5 divided by 9. In here it's important to have float division, not integer division. Okay, let's put spaces. And this should be it. So 32 minus 32, this thing I can see it's 0 times, does not matter how much, it's going to be 0 degrees Celsius. And then 212 minus 32. So that's the temperature at which the water boils. Let's see if the result is okay. And it is. Okay, now we have a number of questions. The first one, the logical operator AND returns true when at least one of the conditions it binds is true. No, with AND it's a binary operator. Both operands need to be true. So incorrect. The logical operator AND returns true. Okay, we did that thing. In what cases is indentation mandatory in Python? Following a line of code starting with if, for, while, and not only. The other options are never, which is wrong. As long as it makes aesthetic sense, certainly not, and when writing a comment. So the answer is probably okay. Next. In a condition control flow structure, for every if statement, you need to include at least one else statement. So if you include the else statement, you will have an else block. But there's plenty of if alternative structures that have only the then block. So at least one else statement is false. We must be careful when creating for loops, since it is very common to fall into cycles that are executed infinitely because an exit condition is not defined. In for loops, the exit condition is defined by default. So this is false. When an action does continue, perform when presented. What action does continue perform when presented within a while loop? Does not exit the loop. It says it does not affect the program. It does affect the program, breaks the current iteration and returns to the top of the loop to continue running. So it ends executing lines from the block of the while loop and returns back to the line where it says while. So breaks the current iteration and returns to the top of the loop to continue running. What function would you use to quickly create a sequence of numbers given any start and end values? Sequence of numbers, start and end, that's range. What method in the random library would be convenient to use to obtain a real number between any two values? If real number means float number, then between two values, that's uniform. Okay, so all of the answers were okay. Next up, there's 3 exercises for loops. We're given this data and says using for loops, greet all members of a class, all students, printing hello plus their name. For example, hello Norville, hopefully with a space there. Okay, students Norville, Fred, Velma, and Daphne. Okay, so that would be for item in students, print, and then item, Shift F10. So this prints just the individual items in the list, but we must prefix this thing with hello and then a space. So that, of course, can be done in 2 ways, like this, with 2 parameters to print, or with string concatenation, like this. So let's try this version. Shift F10. And it's okay. Loop, for loop, exercise number 2. Given the following list of numbers, 1, 5, 8, etc. until 4, calculate the sum of all of the numbers using for loops and store the result in a sum variable called sum numbers. Okay, so sum numbers should start at 0 because we're doing sum. If we were doing the product, we will start at 1 because it makes no sense to multiply something with 0. Okay, so for item in list numbers, we're going to print first. Let's see the individual values. Shift F10. So indeed, in item, the loop variable will have all of the items in the array. In the list, okay? And how do we create a sum? We create a sum by using the previous version of the sum, and the sum should start at 0, which it does. We should say sum is the sum plus the item. Where is it? We'll need to print it. And it's 113. The same thing can be done by using plus equals like this. Still 113. And the final exercise for 4. We have a list of numbers. And we should perform the sum of all even and odd numbers separately in the variable sum even and sum odd. The modulus or remainder of a number divided by 2 is 0 when the value is even. Modulo remainder of division by 2 is 1 when the number is odd. And then it gives 2 examples. Let's put them in comments. Okay, so sum even and sum odd. We should iterate through all of the numbers in the list of numbers and see which, if the current item in the list is odd or even. If it's odd, we'll put the current value in the sum odd. If it's even, we'll put the current value in sum even. So again, sums always start with 0, products always start with 1. These are 2 sums. For item in list numbers, we'll print first. Then we'll need to check if it's odd or even. We'll check just for even. So if item modulo 2, I'm not sure what's the priority of operations. So if this is 0, if the remainder is 0, this is a even. And we should increment the sum even. So that's the block, the then block, just 2 lines, 15 and 16. We print that it's even, and then we add the item to sum even. The else block means that the modulo, so the remainder of division by 2, is not 0. The only other possibility is 1, which means it's odd. And we're going to increment the sum odds. Okay, and we'll print both things with pretty format. Sum of even numbers in the list is sum even, sum of odds is SE and dot. Trailing new line. Control S. And let's run this thing. Shift F10. So it goes through all of the items in the list. Starts with 1. 1 is odd, which is true. 5 is odd, which is true. 8 is even. 7 is odd. 6 is even. 8 is even. So it computes correctly if it's even or not. And then the two sums are 68 and 68, so they're identical. Okay, let's see if this works. And it's okay. Next up, 3 exercises for the while Python keyword. So we are given a local variable named number with value 10. We should create a while loop that prints the numbers 10 to 0 on the screen one at a time. So a while loop, let's do that. While requires a condition similar to if. What would the condition be? We need to print 10 to 0, so including 0, which means if number is greater than or equal to 0, we'll need to print it. Okay, so we take the number 10. If it's greater than 0, we'll print it. This is an infinite loop. Let's stop it while we can. So we are asked to print the number 9, then the number 10, and then not the number 10, but the number 9. So 10, 9, 8, 7, etc. Which means that this is the loop variable number. We start at 10, which is a number that we should print. We stop at 0, which is a number that we should print, but then the value of number should decrease, which can be done in two ways. Either number -1, like this. So values 0, 10, 9, 8, etc. until 0. Or we can decrement it. Let's see if minus equals exists. It exists. If not, we can increment it by -1. It's the exact same thing. So it's okay. Next, exercise number 2, for loops. We are given a local variable number integer value 50. Create a while loop that subtracts one by one the numbers from 50 to 0, including 50, included 0, subtracts one by one the numbers from 50 to 0. If the number is divisible by 5, show that number on the screen. We'll use the modulus with 5. If the number is not divisible by 5, continue executing the loop without showing the value on the screen. I'm not sure what subtracting is meant here to be. Let's look at the requirement. Create a while loop that subtracts one by one the numbers from 50 to 0. I'm going to guess that it goes from 50 down to 0. And then if the number is divisible by 5, so similar to an even number, show on the screen just the number. If the number is not divisible by 5, such similar to odd numbers, continue executing the loop without showing the value on the screen. Okay, so let's do first a loop that goes from 50 including to down to 0 including. So that would be while number greater than or equal to 0, print number, and let's not forget to decrement number minus equal to 1. Okay, so it prints all of the numbers including 0 and starting with 50. And then we'd say that subtracts one by one the number. If the number is divisible by 5, show the number on the screen. Number divisible by 5. So that's if number modulo 5 equals to 0, then print so if the number is divisible by 5, show that number on the screen. If the number is not divisible by 5, continue executing the loop without showing the value on the screen. We don't, because that would execute the else branch, which we do not have. Okay, so this should be it. It only shows the numbers between 50 and 0 inclusive, which are multiples of 5. We can also run with the debugger to see what's happening here. So step over F8. 50 greater than or equal to 0 true. We enter the body of the while. 50 is 5 times 10. We print 50. We exit the body of the then block. Then we're in the body of the while block. Number is 50, we'll decrement it, will become 49 in here. We can see 49 here and here. 49 greater than or equal to 0, but not divisible by 5. There's no else block for this if, so the if statement is going to be skipped. It will continue executing the rest of the statements in the while block, which is line 6. 49 becomes 48, which is positive, not divisible by 5. 47, positive, not divisible by 5. 46, positive, not divisible by 5. 45, positive, divisible by 5. We enter the then block, which does line 5 only and prints 45 at the console. Okay, and the final exercise for whiles. So we have loop interruption statements. Create a for loop through the following list, printing each of its elements on the screen, and interrupt the flow when you find a negative number. You must not change the order of the list. Okay, so we loop through all of the items. For item in list of numbers, we print everything. Okay. Create a loop through the following list, printing each of its elements, interrupt the flow when you find a negative value. So when we find the first negative, we should exit the for, I guess, and totally not print it. Or print it. We'll print it. We'll see. The requirements of the program are not really clear. So if we find a negative number, which means strictly less than 0, then we should break. Let's see how that looks like. So it goes 4, 5, etc., 6. Then -1, prints -1, and because it's negative, we break. So the body of the for is not executing any longer. The entire for statement is not executed any longer. So we do not return to line 3, we exit the statement for, which starts at line 3, ends at line 6 inclusive, so it goes to line 7, which is the final line, so the execution stops. Let's see if this is what is asked that we do. No, because it prints -1. So should not print -1. Okay. So if item greater than or equal to 0, we can print. Otherwise, we cannot print. So now the list should end with 9, 5, 6 without any -1. And this is it, successful. Next up is 3 exercises for range. Says that create a list consisting of all of the numbers from 250 to 500. Store this list in the variable myList. Okay, so that would be range. And the syntax is start inclusive, so 2500, and stop exclusive. So we need to stop at 2585 plus 1. And then that's it. Let's print it. Create a list, so not a range. We need to convert this thing to a list. Shift F10. So starts at 2500, goes ascending each of the integer numbers until 2584, 2585, which is inclusive, correct. Okay, range practice number 2. Using the range function, create in a single line of code a list of numbers that are multiples of 3 from 3 to 300 inclusive. Store this list in the variable myList. Okay, so we should use just one line to create the list. We should use range, not list comprehensions. All of the numbers multiple of 3 to 300. So let's see how that is. Starts at 3. Let's copy the short explanation. From 3 to, so start is definitely 3 because 3 is included. Then 300 is the end, not included, so we need to go +1. And then multiples of 3, so that means 3, and 4, 5 not, 6 yes, 7, 8 not. So that's a step of 3. Shift F10. 3, 6, 9, correct. Range practice number 3. Use the range function and a loop to add the squares of all the numbers from 1 to 15. Store the result in a variable called sum squares. Create a range of values that you can iterate through in a loop. For each of these values, square it, power of 2. Sum all of the squared values obtained, accumulate the sum in the variable sum squares. Okay, so the explanation is this thing. The sum local variable is named sum squares. Some local variables always start with 0. We should have a for loop. It says like this, so for item in some range. What's the range? Of all of the numbers from 1 to 15 inclusive. So that's can be done in multiple ways, but let's do it with start 1 and end 15 plus 1. And we should compute the square of the item. So that would be item times item. And we should append that thing, add that thing to sum squares. So ss tab plus equals that. And then we print the final result, ss. Shift F10. So one, we could print the item to the power of 2, so that would be 1, 4, etc. 1, 4, 9, 16. Hopefully this is what it is asked of us to do. So that's correct. Next up is exercises with enumerate. Print sentences like the following on the screen. Name is found at index, where name must be each of the names in the list below, and the index must be obtained using enumerate. The list is list names Stephen, Jackie, Donna, Kelso, Eric, Fez, Kitty, Red. You can use the given print lines as an example and change its variable names, but the returned phrases must be the same. You must use loops. Okay, so we know this name, how to obtain it. So that would be for name in list names. But then how do we obtain this index? We could obtain it by declaring a local variable. So int index equals to 0, and then we increment the index plus equals to 1, shift F10, not int. Okay, so Steven found at index 1, Jackie found it at index 0, Jackie found at index 1, Donna at index 2, etc. 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 elements, and the last one is with index 7, correct. But it says that we should not use a local variable, this index. Instead, we should use enumerate. So let's do enumerate. And because we can see the names of two variables inside of the body of the for loop, we can guess that it uses Python unpacking. And the order is the other way around. Okay, so the output should be the same, shift F10, and it's the same output. So this is a destructuring, which is called Python unpacking. Enumerator returns a list of tuples. At each for iteration, we have just one tuple. The first one is 0, Steven. At the second iteration is going to be 1, Jackie. Enumerator practice number to create a list formed by the tuples index and element. Create a list formed by the tuples index and element. That's how tuples are when you use enumerate. Obtained through enumerating the indices of each character of the Python string. Call the returned list with the variable name indices list. I'm not sure what's asked for us to do. So indices list is enumerate. And then something iterable, a string is very iterable. And then we'll print both the type and the value. So it's the wrong type. Indices list says should be a list. Instead, it's a object of the class enumerate. Call the returned list with the name variable name. So the name of the returned, the local variable indices list should be in fact be a list. Okay, for that we convert the object of type enumerate to a list. And now it's what we wanted. So on first position, There's a tuple 0 and p, then the tuple 1 and y, tuple 2 and t, etc. Next up, exercise number 3. We have a list of names. Print to the screen only the indices of those names in the list that start with an M. You can solve it in different ways, but it will help you keep in mind some of the following elements: loops, ifs, enumerate, string methods, and indexing. Okay, says print to the screen only the indices of the names that start with M. Okay, so we're asked to do the same thing, which is iterate with a for, which will need to have destructuring. So should be index and name in, and then we should use enumerate and the list of names. So now we're inside the body of the for. We have two local variables inside of the body. We have index, which goes 0 through 8, and name that goes from Maverick to Mills. And then says we should ignore the names that do not start with an M. The names that, for the names that start with an M, we should print the index. So if name starts with an M, that's name dot how do we use? Doesn't know that name is a string. Let's create a local variable here. Starts with M and print. Looks okay. So if the name starts with M, then we should print only the index, nothing else. So me starts with M, yes. The names all start with an uppercase letter, so we could just compare with an uppercase M. Otherwise, we would need to make these things like this, upper, and then starts with M. It's the same thing. This is really not needed. Shift F10. So 0, Maverick starts, yes. 1, 2, Madeline starts. 4, 5, yes. 6, 7, 8, and 8 also. So this is also correct. Next up is practice exercises for the zip function. So print to the screen phrases like the following example. The capital of Germany is Berlin. Let's have this documentation here. Use the zip function loops and the following lists of countries and capitals to solve it quickly and efficiently. Capitals: Berlin, Tokyo, Paris, Helsinki, Ottawa, Canberra. Countries: Germany, Japan, France, Finland, Canada, Australia. Okay, so we should create a zip and then iterate through it. So that would be or we have an item in, we have a zip, only two array lists, both will be used as parameters. We want capital of Germany is Berlin, so first we're doing countries, and then we're doing capitals, not the other way around. And we're going to print the item. Shift F10. Now says the capital of Germany is Berlin, Germany, Berlin. The capital of Japan is Tokyo, Japan, Tokyo. So we have the two items, 1 and 2, in item 1, which item 1 is a tuple. It's a tuple, we can see it's a tuple because it uses round parentheses. Okay, we need this format. We need to use F. The capital of Germany, this would be item of 0 is, and this thing would be item of 1 because it's a tuple. Or we could use this structuring, which in Python is called unpacking. So we could have country and capital. So this item 1 will be country, and this one would be capital. Shift F10 should show the exact same output in the console, which it does. Okay, the next exercise. Create a zip object made up of lists of a set of brands and product that you prefer inside the myZip variable. Brands and products. What can we do? Let's do brands and products. So this should be lists. So make these lists. Okay, brand, Volkswagen. And product, what product do they have? Golf. What else? Audi. A7. Ford would be Fiesta. Okay, so we have 3 items in each of the 2 lists. The lists contain only strings. We should create a zip object inside the myZip variable. So it doesn't say a list, but a zip. Equals zip of the 2 lists, brands and products. Let's see if it worked. So print list of MZ, and it worked correctly. Okay, next one. Create a zip object with the translations of the numbers from 1 to 5 in Spanish, Portuguese, and English in that order. And then convert the generated object into a list called numbers. Okay, so that's a local variable named numbers, which should be a list, which is a zip of these three local variables in the same order. So this creates a zip object. This converts the zip object to a list. It actually enumerates it. The results should follow the following structure. And it does. We can actually print it. Okay, Ctrl A, Ctrl C. So that's okay. Next up is practice exercise number 1 for min and max functions in Python. So we have a list of numbers. Get the maximum value among the values in the following list and store it in maximum value. Okay. So maximum value should be the maximum value among the values in the list. So that's max and number list. Okay, let's print both things. Print numbers list and maximum value. If F10. When we print number list, all of the items in the list are actually computed because we can see on the last position in the list we have 611 raised at the power of 5, so multiplied to with itself 5 times. Actually 4. Okay. And then the maximum value is 55 to the power of 12, which is this huge number, 766,217, etc. And it's correct. We have a list. Calculate the difference between the maximum and minimum value in the following list of numbers and store it in a variable named number range. Okay, so this is the number list, starts with 445, ends with 665. Calculate the difference between maximum and minimum. So maximum would be max, difference, and then minimum, and then let's print it. F10. So the max and minimum. So this would be, it's really hard to actually see which value is which without putting some sort of separator to see where the thousands start, where the millions start, like this. Okay, and the last exercise with min and max. We have a dictionary with people name, so first name and age. Using min and max dictionary methods, get the minimum value from the following dictionary. Store this value in a variable named minimum age. So we should compute minimum age, not the minimum value, because minimum value will look only at the keys. Also get the name that comes last in alphabetical order. So last name in alphabetical order, that's max of the dictionary. The minimum age, so max only looks at keys, does not look at values. And in order to look at values, we need to go min and then dictionary ages and then dot values. Let's print these two. And last name. Minimum age is Jean, and then max of names, so max of keys, which is the last name, is Vito. And that's okay. Next up is a longer exercise with many requirements, which says like this. So we have we ask the user, then user has 8 tries. Ask user, okay. The program invents a random number between -15 and 255. Okay. Ask user a number. So that would be loop 8 times. Maximum 8 times. And the number might be less, equal, greater, out of range. This range. Okay, so let's create the program. So again, our program uses the random Python library to generate a random number in the interval -15 to 54 inclusive. Then we ask the user please guess a number. The user will enter a number, an integer number. If it's out of range, we're going to tell the user that the number is out of range and that the range is the correct one is -15 to 5, 4. If the number was guessed perfectly, then the program will stop and will congratulate the user. If the number guessed by the user is less than or greater than, the program will tell the user that the number that the user guessed is greater or less. And all of this happens at maximum 8 times. The loop can end even in less than 8 iterations when the user guesses the number correctly. So let's do that. So first of all, we'll need to invent the secret number. So that's secret number. This thing is randint. For randint, we'll need to import from a random import randint. Randint goes from A and B inclusive, so that's -15 to 254. So this is done. Let's loop 8 times to ask the user a number and then decide. So that's exactly like that, loop 8 times. So for I in range 8 times, that would be 8, because it will go from 0 to 7, which is what we want. Ask the user a number, so that's input guess an integer number. Guessed number. And then we'll decide which of the 4. If it guessed the number, so that means guessed number equals to secret number, then it should congratulate. So that's print okay, so it congratulates, and then the entire program should finish, which is done by just exiting the for structure, because we will not have anything after the for. So that would be break. Okay, that's one case, but there are 3 other cases, and all of the 4 cases are mutually exclusive. That's why we want to use elif. Okay, so the secret number, the guess number, is strictly greater than secret number. Then we'll print the secret number is less elif if the guessed number is less than the secret number. Print the secret number is lower. It's higher. Okay, and then out of range, we should start with out of range, yes. So this is elif. So out of range this thing. If, and this is a double condition, the guessed number is strictly less than 15 or any of the two. The guessed number is strictly bigger than, greater than 25 or okay, let's put a debugger in here to see what's actually doing. It doesn't like that okay, so it shows all sorts of errors. First of all, input returns a string and we want guessed number to be a number. So that would be converted to int. Then it doesn't like the parentheses that do not add to readability. So we'll give the number 3 and it's out of the range because we put guessed number less than 15 instead of less than minus 15. Okay. We'll guess the number 3. The secret number is higher, 200. Lower, 100. Lower, 50. Lower, 30. 40. 45. And it's less than 45, but greater than 40. So between 40 and 45 exclusive, both. So there's not enough iterations to actually guess the number. But the program has worked correctly. Let's still run it in the debugger to see what's happening there. Okay, we're at line 11. It says exercise.py at line 11. This thing. Step over. Secret number is 91. Okay, so I goes from 0 to 7. So now we're at line 14. It says guess an integer number. I'm going to go with the middle between 15 and 24 and 250, which is, I don't know, 100. Okay, so the secret number is 91, the guessed number is 100. The guessed number is within range, so it's not less than minus 15, not greater than 254. F8. elif, another condition. The guessed number is not a secret number, so one is 91, the other is 100. Guessed number is 100 greater than secret number. The body of this then block is executed, so print secret number is lower, which indeed it is by 8 units. I need to guess another number, so I guessed 100. It's 90 something. I'm going to guess the middle between minus 15 and 100. That's 60. Okay, we're at line 15 inside the range, so it will skip over the body of the then block, which is line 16. Not equal. 91 is larger than 60. So the secret number is higher than 60, but less than 100. Next time we'll guess the middle, which is 80. Okay. Not equals. Guessed number is less than secret number. One is 80, the other is 91. Prints and then goes back to line 13. We're at iteration 4, which is I equals 3, means fourth iteration. I'm going to guess something between 100 and 80. So that's the middle, which is 90. F8. Guess number is 90 and it's lower than the secret number by 1 unit. Okay, iteration 5 out of 8. I need to guess something between 90 and 100. I'll go with the middle, which is 95. And press enter. Not equals. 95 is greater than 91, so line 21 will be executed. So something between 90 and 95, I'll go with the medium, which is 92. Enter. F8. Not equals. 92 is greater than the secret number. The secret number is lower than 92, but more than 90. So that's only one possibility there, 91. And it's not out of range, so line 16 is not executed. They're identical, 91. I'm being congratulated. This is the 7th iteration out of 8, so the penultimate iteration. Break jumps out of the 4, so it goes at line 24. There's no more Python source code lines. Execution will stop. Process finished. Exit code 0. I guessed.